The night has finally come to settle around you, wrapping the world in a blanket of soft velvet silence. It is time to let go of the day, to release the thoughts that have tethered you to the waking hours, and to surrender to the gentle pull of rest. Find yourself in a position of absolute comfort, where your body feels heavy, supported, and safe. Close your eyes and imagine that the darkness behind your eyelids is not an empty void, but a vast, warm expanse of starless sky, infinite and holding you in a cradle of peace. Breathe in deeply, drawing in the cool, still air of the night, and exhale slowly, pushing away any lingering tension. Let your shoulders drop, let your jaw unclench, let your hands rest open and loose. Tonight, we embark on a journey not to the cold reaches of space, nor to the frantic energy of the city, but to the deep, ancient warmth of the earth itself. We will drift through the slow, rhythmic stories of volcanoes, nature's oldest architects, the glowing hearths of our planetary home. There is something profoundly soothing about the concept of this ancient heat, a reminder that beneath the cool, solid ground we walk upon, there is a vibrant, living energy that has burned since the dawn of time. It is a slow fire, a patient fire, a fire that creates land and breathes life. As you listen to the cadence of my voice, allow your mind to float away from the here and now. Visualize yourself as a weightless spirit, drifting effortlessly over landscapes untouched by time. You are safe, hovering above the world, watching the slow, majestic dance of geology unfold in a time frame that makes centuries feel like seconds. There is no rush here. There is no urgency. There is only the deep, resonant hum of the earth and the hypnotic flow of molten rock, moving like liquid light through the veins of the world. Let this image anchor you. Let the warmth permeate your dreams. Let us begin our descent into the comforting embrace of the ancient earth. Imagine, if you will, the surface of our world as a great protective shell, a sturdy crust that shields us from the depths. But this shell is not unbroken. It is a puzzle of colossal proportions, and occasionally, nature creates a majestic opening, a portal between the surface world of air and wind and the subterranean world of fire and stone. This is the essence of what we call a volcano. It is not merely a mountain, it is a gateway, a rupture in the crust that allows the planet to breathe. Picture a quiet opening in the rock, perhaps high atop a misty peak or deep within a verdant valley. It acts as a vent, a chimney connecting the cool outer atmosphere to the hidden, glowing reservoirs miles beneath your feet. Think of this opening as a pressure valve for the planet, a necessary exhale that maintains the balance of the world. It is a bridge between two realms, the solid, cool certainty of the lithosphere and the fluid, dynamic potential of the asthenosphere below. When you visualize a volcano, do not see it as a force of destruction, but as a point of connection. It is the earth expressing its inner vitality. Just as your pores allow your skin to breathe, these geological vents allow the heat and pressure of the deep earth to escape, regulating the internal temperature of the immense sphere upon which we sleep. It is a natural, rhythmic process, as steady and essential as the beating of a heart, waiting patiently for the moment to open and release the energy stored within the stillness of the stone. As we linger on this image of the connection between the inner and outer worlds, we drift further down, following the path of the heat. Deep beneath that opening, the rock is not solid, but fluid, a glowing, viscous substance we call magma. This is the mother of stone, the primal soup from which islands and mountains are born. In the deep pressurized chambers of the earth, this molten rock waits, glowing with a fierce incandescent orange light, a colour so rich and warm it pulses with life. It is magma as long as it remains hidden, tucked away in the planet's embrace, insulated by miles of heavy dark crust. It swirls slowly, a thick heavy liquid moving with the lethargy of honey in winter. But the moment this substance rises, pushed by the ancient pressures of the deep, and breaches the surface, the very instant it meets the air or the water, it undergoes a transformation of name and spirit. It becomes lava. Visualize this transition. The molten rock emerging from the vent, spilling over the rim like a pot boiling over with gold. As it touches the cool air, its colour begins to shift, darkening from blinding white hot to deep reds, and eventually to cooling greys. This journey from magma to lava is a journey of birth. It is the moment the internal dream of the Earth becomes a physical reality, laying down new layers of land, expanding the edges of continents, and writing the history of the world in lines of cooling fire. Let your mind expand now, zooming out from the single vent to encompass the entire globe. Picture the vast blue expanse of the Pacific Ocean, a serene and mighty body of water that cradles the world. Bordering this ocean is a majestic arc, a horseshoe shape that stretches for thousands of miles, hugging the coastlines of continents and weaving through island chains. This is known as the Ring of Fire. It is a poetic name for a profound reality, a necklace of volcanic activity that encircles the Pacific Basin. It is here, along this great arc, that the majority of the world's volcanoes reside, standing like silent sentinels watching over the sea. Trace the line in your mind's eye. It travels up the spine of South America, along the rugged peaks of the Andes, moves north through the Cascades of North America, arcs across the chilly waters to the Aleutian Islands of Alaska, and then sweeps down through Japan, the Philippines, and into the southern hemisphere towards New Zealand. It is a continuous ribbon of geological power. Envision this ring not as a chaotic line of fire, but as a glowing seam that stitches the ocean to the land. It glows softly in the dark of your imagination, a reminder that the edges of our world are alive, constantly reshaping themselves in a slow, burning circle of creation that has persisted for eons. This great ring of fire exists because of the silent, monumental dance of the ground beneath us. We drift now to the concept of tectonic plates, the massive, rigid rafts of rock that make up the Earth's surface. These plates are not stationary. They are restless wanderers, floating atop the semi-fluid mantle below. Imagine them as colossal puzzle pieces, drifting across a sea of superheated rock, moving at a pace so slow it rivals the growth of your fingernails. Yet, in their slowness, they possess an unstoppable momentum. When these great plates meet, the Earth changes. In some places they drift apart, a divergent dance that opens rifts for magma to rise gently, creating new floors for the oceans. In other places they collide, a convergent embrace where one plate slides beneath another, diving deep into the hot interior to melt and rise again. This is the engine of the volcano. It is the friction of the world rubbing against itself, the heavy oceanic plates sinking beneath the lighter continental plates, creating the heat and pressure that fuels the fires above. Visualize this movement as a slow, heavy ballet, a friction that occurs in total silence to our ears, but with a force that builds mountains and carves trenches, a testament to the immense, patient power of the planet. From the shifting plates, we turn our gaze to the forms these fires create. Picture a mountain that does not rise in a sharp, jagged peak, but rather spreads out broad and low, like a warrior's shield laid gently upon the ground. These are the shield volcanoes. They are born from a specific type of lava, fluid, hot, and fast-moving, that travels great distances before it cools and hardens. Because the lava flows so easily, it does not pile up steep and high. Instead, it creates layers upon layers of gentle slopes, building a mountain that is vast in width and volume. The most famous of these sleeping giants reside in Hawaii. Imagine Mauna Loa, a colossus rising from the sea floor. If you could drain the ocean, you would see that it is taller than Everest from its base to its summit, yet its slopes are gentle enough to walk up without strain. These volcanoes are rarely angry. Their eruptions are often tranquil fountains of fire that create rivers of lava, mesmerizing and steady. Visualize standing at the base of such a gentle giant, looking up at the long, curving horizon line where the mountain meets the sky. feeling the sense of stability and permanence that comes from such a broad, anchored foundation. Now let the image shift. The landscape changes. The gentle slope becomes a steep, majestic cone, rising sharply toward the heavens. These are the stratovolcanoes, the classic picturesque mountains that grace postcards and ancient paintings. Think of Mount Fuji in Japan or Mount Rainier in the Cascades. They are built differently, constructed from alternating layers of hardened lava, ash, and stone. A geological layer cake that tells the story of thousands of years of activity. They are the composite memories of the Earth, stacked high into the atmosphere. These mountains are imposing and grand. They're often capped with eternal snow, a brilliant white contrast against the dark volcanic rock and the blue sky. The symmetry of a stratovolcano is hypnotic. It draws the eye upward, leading the spirit toward the clouds. They are the watchers of the horizon, tall and solitary. Visualize the clouds drifting around the peak of such a mountain, perhaps catching the pink light of a setting sun. The structure is steep, requiring effort to climb, representing the pinnacle of the Earth's ambition to reach the sky. They stand in quiet dignity, beautiful and formidable, monuments to the power of vertical growth. But not all volcanoes reach for the sky. Some choose to dwell in the eternal twilight of the deep ocean. We drift now away from the land, sinking beneath the waves down into the crushing, silent dark of the sea. Here, miles below the surface, exist submarine volcanoes. These are the hidden forges of the world, erupting in darkness, unseen by human eyes. When their lava breaks forth, it meets the crushing weight and near-freezing temperature of the ocean water instantly. The reaction is immediate and gentle. The lava cools so quickly that it forms bulbous, rounded shapes known as pillow lava. Picture these black, glass-like pillows stacking upon one another on the ocean floor, billowing clouds of steam rising up only to be absorbed by the infinite sea. There is no sound here but the deep rumble of the water. It is a private creation, a secret building of new Earth in the abyss. Over millions of years, these underwater mountains may grow tall enough to break the surface and become islands. But for now, they remain in the deep, glowing softly in the dark, a testament to the fact that the Earth is active even where we cannot see it. Sometimes, the Earth does not produce a flow of liquid rock, but rather a soft grey blanket that covers the world in silence. We speak now of volcanic ash. Unlike the ash from a wood fire, which is soft carbon, volcanic ash is something far more ancient and permanent. It is pulverized rock and tiny shards of glass, created when gas bubbles shatter the magma into microscopic dust. When it falls, it descends like a heavy grey snow, coating the trees, the ground, and the stones in a uniform layer of softness. Visualize a landscape after such an event. The colours are muted, turned to shades of silver and slate. The sound is dampened, creating a hush that is profound and heavy. It feels like a winter that has nothing to do with cold. Yet, within this grey dust lies a secret gift. This ash is incredibly rich in minerals, a nutrient boost drawn from the deep earth. Where the ash falls, the soil eventually becomes incredibly fertile. It is a cycle of renewal. The grey blanket sleeps for a while, and then life bursts forth greener and more vibrant than before. It is nature's way of feeding the future, a dusting of raw potential waiting for the rain. We must ask ourselves, where does this heat originate? What engine drives the magma, the plates, and the ash? We must travel in our minds to the very centre of the sphere, to the source of the heat. The Earth is not a cold rock floating in space. It is a heat engine, preserving the warmth of its creation billions of years ago. Some of this heat is a memory, a remnant of the kinetic energy from when the planet first coalesced from dust and starlight. But much of the heat is generated even now, in the mantle and the core, through the slow, steady decay of radioactive elements. It is a nuclear fire that warms us from below. Imagine the core as a glowing iron heart, pulsing with a temperature that rivals the surface of the sun. This heat radiates outward, softening the rocks of the mantle, causing them to churn and flow in slow-motion convection currents. It is this deep, pervasive warmth that keeps the planet alive. If the core were to go cold, the volcanoes would sleep forever, and the tectonic dance would cease. Feel gratitude for this heat. It is the thermal heartbeat of our world, a steady, rhythmic warmth that defies the cold of the universe. Finally, we drift to the concept of time and rest. A volcano is not always active. In fact, it spends most of its life in a state of deep slumber. This is called dormancy. A dormant volcano is one that has not erupted in a long time, perhaps centuries or millennia, but is expected to wake again one day. It is not dead, it is merely resting. Visualize a great mountain covered in thick green forests. Birds sing in the canopy, snow rests on the peak. It looks like any other mountain, peaceful and still. But deep beneath the roots of the trees, the magma chamber still holds warmth. It is sleeping the long sleep of geology. To us, 1,000 years is an eternity, but to a volcano it is a mere nap, a blink of an eye. There is a profound tranquility in this potential. It teaches us patience. It reminds us that stillness does not mean absence. The mountain waits, breathing so slowly we cannot measure it, gathering strength, dreaming its own dreams of fire and stone while the civilizations of the world rise and fall around its base. It is the ultimate symbol of rest, a pause in the chaos, a deep, abiding silence that holds the promise of future awakening. From that deep, restorative slumber of the dormant mountain, we drift gently toward a silence that is even more profound, a stillness that stretches into eternity. We move from the sleeping giants to the ancient ancestors of the earth, the extinct volcanoes. These are the mountains that have finished their labor. The fire within them has truly gone out. The magma chamber beneath has crystallized into solid cold stone, and the connection to the burning core has been severed by the shifting of the tectonic plates. They are monuments to a time long past, standing in quiet dignity as the winds and rains of eons slowly reshape their forms. Visualize a jagged spire rising from a flat desert floor, solitary and stark against the setting sun. This is often what remains of an extinct volcano. Over millions of years, the softer outer slopes, the ash and the loose rock, have been washed away by the gentle, persistent hands of the weather. What is left standing is the volcanic plug, the hardened lava that once filled the central vent. It is the skeleton of the mountain, revealed after the flesh of the land has eroded. Picture the famous shiprock in New Mexico, a cathedral of stone rising from the dust, looking like a great vessel sailing through a sea of time. There is a melancholy beauty here, a sense of completion. The extinct volcano does not wait for a future eruption. It simply exists, becoming one with the crust, slowly returning to the earth that created it. It teaches us the grace of endings, the peace that comes when the fire cools and the work is done, leaving behind a legacy of stone that stands against the sky. Sometimes, however, the mountain does not erode away, but transforms through a dramatic inward collapse, creating one of nature's most serene and breathtaking landscapes, the caldera. This occurs when a massive eruption empties the magma chamber so completely that the ground above can no longer support its own weight. The mountain, heavy and hollowed out, bows down, collapsing into itself to form a vast, bowl-shaped depression. It is a moment of great destruction that paves the way for a profound tranquility. Imagine standing on the rim of such a depression, looking down into a world that feels separate from the rest of the landscape. Over centuries, these great bowls often fill with rain and melted snow, creating crater lakes of unimaginable clarity. Because these lakes have no inlet streams bringing in sediment or mud, the water is pristine, a mirror of pure liquid sapphire. Picture Crater Lake in Oregon, the deepest blue you can imagine, a colour so rich it feels like a physical weight on the eyes. The water is perfectly still, protected by the high walls of the caldera rim. It reflects the passing clouds and the star-filled sky with perfect fidelity. In the centre of the lake, a small island might rise, a wizard island, a tiny cinder cone representing a final quiet breath of the volcano. The caldera is a place of stillness born from chaos, a sanctuary of water cradled in the arms of broken stone, reminding us that even after the greatest falls, a new and beautiful balance can be found. The water that fills these craters reminds us that fire and water are not always enemies. Often, they are partners in healing. We drift now to the soothing phenomenon of hot springs. In regions where the volcanic heat still lingers near the surface, groundwater seeps down through fractures in the rock, travelling deep into the dark, warm crust. There, it is heated by the magma below, absorbing minerals, sulfur, calcium, lithium, before rising back to the surface as a gift of warmth. Visualize a natural pool nestled in a snowy valley, steam rising in soft white ribbons into the crisp winter air. The contrast is sharp and inviting, the biting cold of the wind against the cheeks and the enveloping womb-like heat of the water. Imagine easing your body into this geothermal bath. The heat penetrates deep into the muscles, dissolving tension, untying the knots of the day. You are bathing in water that has touched the fire of the earth. In Japan, these are the onsens, sacred places of meditative quiet. Picture the famous snow monkeys of Jigokudani, eyes closed in pure bliss as they soak in the steaming waters, while snow falls gently on their fur. The hot spring is the Earth's own spa, a place where the terrifying heat of a volcano is tamed into a gentle embrace, offering comfort and restoration to any weary traveller who finds the source. Sometimes, this underground water is under too much pressure to pool quietly. It demands to be heard, to dance. We move from the still pools to the rhythmic power of the geyser. Here, the water is trapped in narrow channels deep underground, constricted and squeezed by the rocks. As the magma heats this water, the pressure builds and the water becomes superheated, staying liquid even past the boiling point, trembling with stored energy. Finally, the pressure becomes too great, and the water flashes into steam, exploding upward in a majestic column of white spray. Visualize the most famous of these, Old Faithful, or perhaps a hidden geyser in the wilds of Iceland. The ground rumbles slightly, a warning whisper, and then, with a rushing sound like a great exhale, a fountain of boiling water shoots high into the sky. It creates a temporary monument of water and mist, glistening in the sunlight, reaching for the clouds before falling back to earth in a heavy rhythmic rain. This cycle, the heating, the pressure, the release, the quiet refill, is a geological clock. It beats with a regularity that is almost biological. Watch the steam drift away on the breeze, the water retreat back into the earth, leaving the silica-crusted ground glistening and wet. It is a reminder of the dynamic pressure that lives beneath us, a release valve that turns thermal energy into a spectacle of vertical grace. In places where there is less water to feed the fountains, the earth breathes in a different way. We find ourselves wandering through a landscape of fumaroles. These are openings in the earth's crust, often found on the flanks of volcanoes, where volcanic gases and steam escape into the atmosphere. Unlike the violence of an eruption, a fumarole is a constant, steady sigh. The landscape here often looks alien, painted in shades of yellow, ochre and white, coloured by the sulfur crystals that form around the vents. Picture a hillside veiled in perpetual mist. The ground is warm to the touch. Everywhere you look, small plumes of white steam are rising from cracks in the rocks, twisting and curling like spirits released from the underworld. There is a scent here, sharp and metallic, the smell of the deep earth, sulfur and minerals. It is the breath of the volcano. In the cool of the morning, the steam clouds are thick and heavy, obscuring the path, creating a dreamlike atmosphere where shapes emerge from the fog and vanish just as quickly. The sound is a soft hissing, a continuous white noise that blocks out the rest of the world. Standing amidst the fumaroles feels like standing on the back of a living, breathing beast, feeling its respiration, witnessing the exhalation of the planet in its rawest, most gaseous form. When this acidic steam and hot water rise up through soil rich in volcanic ash and clay, the result is one of the most textured and curious sights in nature, the mud pot. Here, the rock has been dissolved by the acidity of the geothermal fluids, turning solid stone into a viscous, bubbling slurry of clay. It is a vat of liquid earth, boiling and churning in a slow, hypnotic rhythm. Visualize a pit of grey, bubbling mud. The texture is thick, like heavy paint or melting chocolate. As the steam rises from below, it pushes the mud up into domes that swell and burst with a satisfying rhythmic plop. The sound is distinct, wet, heavy, and percussive. Bloop, plop, bloop. It is a slow-motion dance of earth and heat. The colours can be surprisingly varied. Depending on the minerals present, iron, sulphur, organic matter, the mud can range from slate grey to rust red, creamy white, or even pastel pink. These are sometimes called paint pots. Watch the bubbles form, stretching the surface tension of the thick clay until they can hold no more, collapsing back into the pot to be recycled. It is a playful, messy expression of volcanic heat, a kitchen of the earth where the ingredients of the crust are stewed and mixed into a primal soup. From the soft, yielding clay, we turn our minds to its opposite, a substance born of fire but sharp as a razor. We speak of obsidian. This is volcanic glass, created when lava rich in silica cools with terrified speed. It cools so quickly, perhaps by hitting water or cool air instantly, that the atoms within the molten rock do not have time to arrange themselves into crystals. They are frozen in place, chaotic and disordered, creating a true glass. Visualize a flow of obsidian, a river of solidified night. The stone is jet black, yet when you hold a piece up to the sun, the edges are translucent, glowing with a smoky golden light. It is smooth to the touch, slick and cool, but its edges can be sharper than the finest surgical steel. Ancient cultures revered this stone, napping it into arrowheads and blades, tools of survival born from the volcano. Picture a field of obsidian boulders glinting under the moonlight. They reflect the world around them like dark mirrors. It is the frozen shadow of the volcano, a material that captures the paradox of the eruption. Fluidity frozen in an instant, darkness that shines, a chaotic atomic structure that results in a surface of absolute glossy perfection. While obsidian is heavy and dense, the volcano also creates a stone that defies gravity. We drift to the concept of pumice. This rock is the foam of the eruption. When magma is depressurized quickly, the gas trapped inside expands rapidly, turning the rock into a froth, a stone soufflé. As it cools and hardens, these gas bubbles are trapped forever, creating a rock that is more air than stone. Imagine holding a piece of pumice in your hand. It is rough, textured like a sponge, a pale grey or cream colour. It feels impossibly light, confusing your senses which expect the weight of a rock. If you were to toss this stone into a pool of water, it would not sink to the bottom. It would bob on the surface, a stony boat floating on the waves. Massive rafts of pumice have been known to float across oceans for years after an eruption, carrying seeds and small animals to new islands. Visualize a grey stone drifting gently on the blue open ocean, rocking with the swell, a voyager sent from the fiery heart of a mountain to cross the cool expanse of the sea. It is a testament to the transformative power of air and fire mixing, creating a rock that yearns for the sky and rides the water. From the chaotic froth of pumice, we move to a creation of perfect mathematical order, the basalt column. This occurs during the cooling of thick lava flows. As the basaltic lava cools, it contracts, shrinking in volume. But it does not crack randomly. It fractures with geometric precision, forming long hexagonal pillars that look as though they were carved by the hands of giants. Visualize the Giant's Causeway in Ireland or the Devil's Postpile in California. Thousands of these stone columns stand side by side, packed together like the cells of a honeycomb. Most are six-sided, fitting together perfectly, creating a stepping stone path that disappears into the sea or rises up as a sheer cliff face. The stone is dark, usually grey or black, and hard. The uniformity is hypnotic. It looks like the ruins of an ancient temple built by a forgotten civilization, yet it is entirely natural, a result of the physics of cooling. Picture yourself walking across the tops of these columns, stepping from one hexagon to the next. There is a rhythm to the landscape, a structure that feels calming to the mind. It is nature displaying its hidden knowledge of geometry, proving that even in the aftermath of a chaotic flow of fire, there is a fundamental law of order and balance waiting to assert itself. Beneath the surface of these hardened flows, there often lies a hidden world, a secret passage known as a lava tube. When a river of fluid lava flows down the side of a volcano, the top layer, exposed to the air, cools and hardens first, forming a solid crust. This crust acts as an insulating roof, keeping the lava beneath it hot and flowing. Eventually the eruption ceases and the liquid lava drains away, leaving behind the empty outer shell, a long, hollow tunnel winding through the earth. Visualize entering the mouth of such a cave. The air inside is cool and still, protected from the sun. The floor is often smooth, marked by the flow lines of the last river of fire that passed through. The walls are lined with lava sickles, droplets of rock that froze as they dripped from the ceiling. It is a tubular cathedral of darkness. You can walk for miles underground, tracing the veins of the volcano. There is a profound silence here, dampened by the thick walls of stone. It is a space of protection. Throughout history, humans and animals have used these tubes as shelters. Imagine the echo of your footsteps in this cylindrical dark, walking through the ghost of a lava flow, safely encased in the hardened memory of the volcano's energy. It is a journey into the interior, a path cleared by fire so that we might walk in the cool, quiet dark. Emerging from the cool, echoing silence of the lava tube, we find ourselves blinking in the soft light, leaving the subterranean veins of the earth to stand once more under the open sky. But let us travel now to a landscape where the fire of the volcano meets its absolute opposite, the crushing, frozen weight of a glacier. Here, in the high latitudes or atop the highest peaks, we witness the birth of a tuya, a mountain shaped by the battle between magma and ice. Visualize a time when a great ice sheet covered the land, a world of white silence miles thick. Beneath this frozen blanket, a volcano wakes. It erupts not into the air but into the bottom of the glacier. The lava pushes upward, melting a cavern of water within the ice, growing steadily in the dark, cold wetness. It piles up layer by layer, cooling instantly against the meltwater, building a steep-sided pile of pillow lava and shattered rock. It is a secret mountain, growing in a womb of ice. Eventually, if the eruption continues, the peak breaches the surface of the glacier, breaking through the ceiling of ice into the air. Now the lava flows horizontally, spreading out over the top of the surrounding ice sheet like batter on a griddle. It creates a perfectly flat, expansive plateau. Thousands of years later, when the ice melts away, what remains is a distinct flat-topped mountain with steep, cliff-like sides, standing alone in the wilderness. It looks like a great dining table set for the gods. Visualize the geometry of this form, the sharp, vertical rise from the valley floor and the unnaturally level summit. It is a monument to a specific moment in time, a fossil of a vanished glacier recorded in stone, standing as a testament to the time when fire overcame the ice. From the high, flat tables of the tuyas, we descend to the lowlands, to a landscape marked not by mountains that rise, but by hollows that sink. We drift over the concept of the maar. These are the shallow circular craters carved into the earth, created by a sudden violent conversation between rising magma and the groundwater table. It is not a mountain building event, but an excavation. When the hot magma encounters the water-soaked rock near the surface, the water flashes instantly to steam. The expansion is explosive, blasting a hole in the crust, blowing out the rock and soil rather than piling it up. What is left behind is a low-relief crater, a ring of debris surrounding a quiet depression. Because these craters are often cut deep into the water table, they almost always fill with water, becoming serene, circular lakes. Visualize a Mar in the Eifel region of Germany, or the volcanic fields of Auckland. They look like eyes gazing up at the sky. The water is often dark and still, bordered by a low rim of green vegetation. There is a profound sense of calm here, a stillness that belies the violent burst of steam that created it. It is a place where the earth exhaled with great force, and now, in the aftermath, the water gathers to heal the wound, creating a mirror for the clouds and the passing birds. It is a geological dimple, a gentle depression that cradles the rain, reminding us that the Earth's power can carve downwards just as easily as it builds upwards. As we stand by the quiet waters of the Mar, we look up. The air above a volcanic landscape is not always clear. Often, it is draped in a soft, ethereal veil known as VOG, or volcanic smog. This is the breath of the active volcano lingering in the atmosphere. It is created when sulfur dioxide and other gases released from the vents react with sunlight, oxygen, and moisture to form a fine mist of aerosols. It is not a heavy, choking smoke, but a pervasive haze that softens the horizon, blurring the line between the ocean and the sky. Visualize the sunlight filtering through this haze. The VOG scatters the light, stripping away the harsh blues and leaving behind the warmer tones of the spectrum. The result is a perpetual golden hour glow, but the true magic happens at sunset. When the sun dips low, shining through the layers of volcanic gas, the sky ignites with colours that defy description. Deep, bruised purples, fiery oranges, electric pinks, and sombre reds. It is a watercolour painting in motion, vast and consuming. The sun itself appears as a distinct red sphere, defined clearly against the haze. While VOG reminds us of the chemical power of the volcano, visually it acts as a lens, transforming the world into a dreamscape of soft edges and vibrant, surreal twilight. It wraps the island or the mountain in a blanket of diffused light, making the world feel quiet, enclosed, and intimately warm. Within this haze, amidst the ash and the clouds of an erupting column, a new energy is born, a spark that rivals the fire of the lava. We witness the phenomenon of volcanic lightning. This is the storm within the plume, as billions of particles of ash, rock, and ice collide with one another in the chaotic updraft of an eruption. They generate immense static charges. The friction of stone rubbing against stone at hundreds of miles an hour builds an electrical potential that demands release. Visualize the dark, billowing column of ash rising miles into the atmosphere, a heavy, charcoal grey monster blotting out the sun. Suddenly the darkness is shattered by jagged, branching bolts of lightning. But this is not the white-yellow lightning of a rainstorm. Often, volcanic lightning glows with strange, intense hues of violet, blue and red, coloured by the gases and debris in the air. It is a dirty thunderstorm, a display of raw, crackling energy confined entirely within the volcanic cloud. The thunder here is muffled by the heavy ash, a deep guttural growl rather than a sharp crack. It is a visual symphony of the Earth's forces, thermal energy creating kinetic energy, creating electrical energy. It looks like the synapses of the Earth firing, a neural network of light illuminating the chaotic birth of new land. It is terrifyingly beautiful, a reminder that the volcano commands not just the earth and fire, but the sky and the spark of the storm as well. As the lightning fades and the energy dissipates, the material within the cloud begins its slow descent back to the surface. We turn our attention to the collective name for all this airborne debris, Tephra. The word itself feels light on the tongue, ancient and Greek. Tephra is everything that the volcano throws into the air, From the finest dust to the largest boulders, it is the texture of the eruption. Drift your mind over the sensation of this falling earth. First, there is the ash, soft as flour, which we have spoken of. But then there are the lapilli, Latin for little stones. These are small, porous pebbles, the size of peas or walnuts, that rain down like hail. Imagine walking on a landscape covered in fresh lapilli. It crunches satisfyingly beneath your feet, a sound like walking on coarse sugar or dry snow. It is light, aerated rock, often black or reddish-brown. It covers the ground in a uniform pebbled carpet. Then there are the blocks, heavy angular chunks of the old mountain torn loose and thrown aside. Tephra is the way the volcano redistributes itself. It is a process of disassembly and reassembly. Visualize the gentle patter of the lapilli falling on the leaves of a forest, a dry rain of stone that accumulates slowly, burying the old world to create a foundation for the new. It is the gritty, textured blanket that creates the unique soil profiles of volcanic islands, a gift of minerals wrapped in the guise of falling stone. Among the tephra, there is a specific aerodynamic traveller that captures the imagination, the volcanic bomb. These are large globs of magma, ejected while still liquid and glowing, launched high into the air like cannonballs. As they fly through the cool atmosphere, they spin. This rotation shapes them, twisting the cooling lava into streamlined forms, football shapes, ribbons, or spindles with twisted ends. They are the sculptures of flight. Visualize the trajectory of such a stone. It leaves the vent as a bright orange blob spinning rapidly. As it arcs through the sky, the outer skin cools and hardens into a crust, while the inside remains molten. By the time it strikes the ground, it is a solid projectile, landing with a heavy, dull thud, perhaps cracking open to reveal the still glowing heart within. Some develop a surface texture known as bread crust, cracked and checkered like a loaf of fresh sourdough, caused by the expansion of gas inside the hardening shell. These bombs are the messengers of the deep, individual parcels of the mantle that have taken a brief, soaring flight before becoming part of the landscape. They lie scattered on the slopes of the volcano, heavy and distinct, frozen in the shape of their journey, permanent records of the moment the Earth defied gravity. The volcano affects not only the air and the stone, but the water that flows upon the mountain. When the heat of an eruption melts the snow and ice on a peak, or when heavy rains mix with loose ash, a terrifyingly powerful slurry is formed, the lahar. This is a volcanic mud flow, but the word mud is too gentle. A lahar is liquid concrete. It flows with the fluidity of water but carries the weight of rock. Visualize a river valley leading away from the mountain. There is a sound first, a low, continuous rumble that shakes the ground, louder than thunder, steady as a freight train. Then the grey torrent appears. It moves faster than you can run, sweeping up giant boulders, trees and bridges, carrying them along as if they were twigs. The surface of the lahar is roiling and grey, steaming slightly. It fills the valley wall to wall. Yet, in this destruction, there is a geological purpose. Lahars are the great levelers. They transport millions of tons of material from the high peaks to the lowlands in a matter of hours. When they stop and dry, they form vast, flat plains of concrete hard rock. Many of the flatlands where cities now sit are built upon the ancient dried flows of lahars. It is a reshaping of the map, a liquid landslide that smooths the rugged edges of the world, leaving behind a blank slate of grey stone. Far hotter, faster, and more ethereal than the heavy mud is the glowing cloud known as the pyroclastic flow, or historically the nuée ardente, the burning cloud. This is the most majestic and formidable expression of volcanic energy. It occurs when the column of ash above a volcano becomes too heavy to stay aloft and collapses, or when a lava dome shatters. A mixture of superheated gas, ash and rock cascades down the mountainside, ignoring the friction of the ground. Visualize this avalanche of heat. It does not slide, it floats on a cushion of hot gas, allowing it to move at speeds that rival a race car. It looks like a billowing grey and red cauliflower cloud hugging the ground, surging forward with a silent, fluid grace from a distance. Inside, the temperature is hot enough to incinerate wood instantly, but from the safety of our dreamlike vantage point, we see only the mesmerizing flow of the cloud. It moves like a living thing, expanding and contracting, pouring over ridges and into valleys like water, yet it is made of fire and air. It glows from within, a red heart beating inside the grey cloak. It represents the absolute state of flux, matter that is neither solid nor liquid nor gas, but a chaotic mixture of all three, racing to find equilibrium. It leaves the landscape sterilized and buried, a clean sweep that resets the biological clock of the mountain to zero. We drift away from the heat of the surface, travelling far, far away from the sun, descending once more into the eternal night of the deep ocean. Down here, along the mid-ocean ridges where the tectonic plates pull apart, we find the hydrothermal vents, often called black smokers. These are the chimneys of the abyss. Seawater seeps into the crust, is heated by the magma and blasts back up, laden with dark minerals. Visualize these chimney-like structures rising from the desolate ocean floor, spewing plumes of what looks like black smoke into the crystal-clear water. But it is not smoke. It is superheated, mineral-rich water. In this pitch-black environment, totally cut off from the energy of the sun, life should not exist. Yet, huddled around these vents is a vibrant alien ecosystem. Giant tube worms, red-tipped and swaying in the current, ghostly white crabs, shrimp that dance in the dark. They are fueled not by photosynthesis, but by chemosynthesis, eating the chemicals from the volcano. This is a garden grown by the heat of the earth alone. It is a profound realization. The volcano is a giver of life, not just a taker. In the coldest, darkest places on the planet, the internal fire provides a sanctuary, an oasis of warmth and energy where life flourishes against all odds, huddling around the hearth of the planet's crust. Finally, we sink even deeper, past the ocean floor, past the crust, into the upper mantle itself, where the pressure is unimaginable. Here, carbon atoms are squeezed by the weight of the world until they align into the perfect crystal lattice of a diamond. These gems are born in the deep, ancient roots of the continents, but they would remain hidden forever were it not for a specific, violent type of volcanic delivery system, the kimberlite pipe. Visualize a narrow, vertical, carrot-shaped tube that punches up from the mantle through the crust. This is a supersonic eruption, travelling at max speeds, driven by deep, expanding gases. It acts as an elevator from the deep earth. As the magma shoots upward, it tears chunks of the mantle loose, rocks containing these precious diamonds, and carries them to the surface before they can melt or turn back into graphite. When the pipe cools, it leaves behind a blue-grey rock called kimberlite, studded with the hardest stones in existence. Think of the journey of a single diamond, forged in the crushing dark billions of years ago, waiting in silence, and then suddenly carried on a rocket ride of magma to the sunlight. The sparkle of a diamond is the sparkle of the deep earth, a captured piece of the mantle's pressure, delivered to us by the violent grace of a volcano. It is the ultimate hidden treasure, a gift from the pressure and the fire. From that crystalline clarity of the diamond, forged in the crushing deep and delivered to the light, we expand our vision. We move from the microscopic perfection of a gem to a scale so massive it defies the human ability to perceive it from the ground. We drift now over the sleeping colossus known as the supervolcano. Unlike the stratovolcanoes that stand as distinct pyramids against the skyline, a supervolcano is often invisible to the naked eye because it is simply too vast. It does not build a mountain, it consumes a landscape. Visualize yourself floating high above the Yellowstone National Park in North America. To the person walking on the ground, there are trees, rivers, and bison grazing in the meadows. But from your high vantage point, you begin to see the subtle curve of the land, a ring of mountains that are not separate peaks, but the eroded rim of a caldera measuring dozens of miles across. The entire park is the volcano. You're walking inside the mouth of a sleeping giant. The magma chamber beneath this land is not a small pocket. It is a sprawling subterranean sea of molten rock, breathing slowly, rising and falling over millennia. This rising and falling is literal. The ground at Yellowstone inches upward and downward like the slow chest cavity of a sleeper in deep REM cycles. There is a sense of awe in this invisibility, knowing that the peaceful forests and the geysers are merely the skin stretching over a reservoir of ancient power. It is a presence that is felt rather than seen, a reminder that the Earth operates on a scale of magnitude that makes our cities seem like toys. Rest in the knowledge of its deep geologic slumber, a sleep that lasts for hundreds of thousands of years, holding its fire in a long, patient pause. From the potential energy of the supervolcano, we shift our focus to the gift that these giants leave behind when they finally do speak. We have touched upon the ash, but now we immerse ourselves in the concept of volcanic fertility. It is a strange paradox of nature that the most destructive force is also the most nurturing. The rock and ash thrown from the depths are laden with elements essential for life: potassium, phosphorus, and trace minerals that have been locked away in the mantle since the birth of the planet. Visualize the slopes of Mount Etna in Sicily, or the lush hillsides of Java. The soil here is dark, almost black, and rich. It feels soft and crumbly in the hand, holding moisture perfectly. Because of this mineral wealth, the vegetation does not just grow, it thrives with a vibrancy that is startling. Picture vineyards where the grapes grow heavy and sweet, their roots drinking from the dissolved minerals of ancient lava flows. Imagine coffee plantations in the volcanic highlands of Colombia, where the beans absorb the unique profile of the earth, translating the geology into flavour. This is the pact between the volcano and the biosphere. The fire takes, but the fire also gives back tenfold. The green that covers a volcanic slope is a green of intense vitality, a testament to the life-giving power of the underground. It is a cycle of renewal, where the grey ash becomes the green leaf, and the memory of fire becomes the sustenance of the living. We lift our gaze now, higher than the mountains, higher than the clouds, leaving the atmosphere of Earth entirely to drift into the silent, star-studded blackness of space. We travel to the red planet Mars to witness the ultimate expression of volcanic ambition, Olympus Mons. On our own planet, the moving tectonic plates prevent any single volcano from growing forever. The plate moves the vent away from the heat source. But on Mars, there are no moving plates. The crust is still. This allowed a single volcano to sit over a hotspot for millions of years, growing taller and wider with every eruption, undisturbed by the shifting of the ground. Visualize this planetary giant. It is not steep like Fuji. It is a shield volcano, a vast, gentle mound. It stands 3 times the height of Mount Everest. If you were to place it on Earth, it would cover the entire country of France. Its base is wrapped in cliffs that are miles high, and its summit pierces the thin Martian atmosphere, standing in the near vacuum of space. Picture the silence here. There is no wind to erode the stone, no rain to wash it away. It is a monument of red dust and ancient lava, frozen in time. The caldera at the summit is a complex nest of overlapping pits, a record of the final breaths of a dying planet. Floating above it, you feel the profound solitude of the cosmos. It is a reminder that volcanism is not unique to Earth. It is a universal language of rocky planets, a cosmic process of heat escaping to the stars, leaving behind mountains that challenge the very curvature of the world they stand upon. Drifting further out into the solar system past the asteroid belt, we come to the realm of the gas giants. Here, in the frigid distance where the sun is but a bright star, we find a phenomenon that challenges our definition of fire. We encounter the cryovolcano on the icy moons of Saturn and Jupiter, Enceladus, Triton, Europa. The magma is not molten rock. It is a slush of water, ammonia and methane, heated not by fire, but by the gravitational tidal squeezing of the massive planets they orbit. Visualize the surface of Enceladus, a blindingly white landscape of pure ice, cracked and fissured like a frozen eggshell. The temperature is hundreds of degrees below freezing, yet from the tiger stripes near the South Pole, great plumes are erupting. But they do not spew ash and lava. They jet streams of water vapour and ice crystals miles into space. It is a cold eruption. The lava flows like a slushy, freezing hard as rock the moment it settles. These plumes create a ghostly, ethereal ring around Saturn, a veil of microscopic ice. Imagine standing on this alien moon, watching a geyser of snow shoot silently into the black sky, powered by the gravity of the giant ringed planet hanging above the horizon. It is a cold fire, a geologic heartbeat in the deep freeze of the outer solar system, proving that the urge to erupt, to release pressure, is a fundamental law of nature, regardless of the temperature. We return now, pulled gently by gravity back to the warmth of our own blue world, to the tropical heat of Hawaii. Here, the wind plays with the lava in a way that creates something delicate and whimsical. We focus on the phenomenon known as Pele's hair. When fountains of fluid basaltic lava erupt into the air, the wind catches the droplets, stretching them out into incredibly long, thin strands of glass. Visualize walking near a vent after such an event. The ground is not covered in rocks, but in what looks like clumps of golden straw. These are strands of volcanic glass, some as fine as a human hair, piled up in drifts against the rocks. They shimmer in the sunlight, a vibrant gold or translucent amber. The texture is brittle and sharp. They're fragile, breaking at the slightest touch. It is named for Pele, the Hawaiian goddess of fire, and indeed, it looks like strands of golden hair left behind by a giant spirit. It is a poetic creation, a moment where the heavy, destructive lava is spun into something as light as spun sugar. The wind carries these strands for miles, draping them over trees and antennas like a spider's web. It is a reminder of the artistry of physics, how a force as violent as an eruption can produce a structure as fragile and intricate as a single strand of glass hair. Connected to this delicate glass is another form, equally poetic, Pele's tears. These occur when the flying droplets of lava cool before they fully stretch into hair, or when the ends of the strands snap off. They solidify into small tear-shaped droplets of black jet glass. They are smooth, aerodynamic and perfect. Visualize holding one of these small black stones. It is the shape of a falling raindrop frozen in stone. It is perfectly smooth, polished by the fire. Often, you will find a tear attached to the end of a strand of hair, a glass bead on a glass string. They lie scattered in the crevices of the lava flow, tiny jewels of the eruption. The contrast is striking. The massive, lumbering mountain that built the island produces these tiny, perfect trinkets. It softens the image of the volcano, giving it a sense of sorrow or emotion, the tears of the earth. It grounds the geological experience in a human metaphor, finding the shape of grief and release in the hardened droplets of molten rock. From the tactile delicacy of glass, we move to the sensation of sound, or rather, a sound that is felt more than heard. We speak of infrasound. A volcano is a noisy beast, roaring with explosions and escaping gas, but much of the energy it releases is below the threshold of human hearing in the low-frequency range. This is the deep, resonant hum of the earth. Visualize standing near a large volcano. You might hear the wind or the distant rumble of rockfall, but your body detects something else. It is a vibration in the chest, a sense of pressure in the ears, a subtle anxiety or awe that seems to come from nowhere. This is the infrasound, the acoustic footprint of the magma moving through the chambers, vibrating the very airwaves at frequencies that travel for thousands of miles. Birds and animals often sense this long before we do, fleeing the area before an eruption. Imagine this sound as the deep bass note of the planet's symphony, a frequency that connects the ground to the sky. Instruments around the world listen for this hum, a global network of ears pressed to the ground. It is the voice of the volcano speaking in a register of pure power, a vibration that reminds us that the Earth is a resonant body, singing a song of pressure and release that we can feel in our very bones. This song of the Earth sometimes changes the sky across the entire globe. We drift to the concept of volcanic sunsets in the atmospheric veil. When a large volcano erupts, it injects millions of tons of sulfur dioxide and fine dust into the stratosphere. These particles do not fall quickly. They circle the globe on the jet stream, creating a thin global layer of aerosols that acts as a filter for the sun. Visualize the years following a great eruption, like that of Krakatoa. The world does not go dark, but the light changes. The particles scatter the blue light and amplify the reds and purples. The result is a season of twilight masterpieces. Artists and poets look to the west in the evening and see skies of blood red, vibrant orange, and unnatural violet. The sun remains visible long after it has dipped below the horizon, its light refracting around the curve of the Earth through the volcanic dust. There is a cooling effect as well, a volcanic winter where the summer heat is tempered by the haze. It is a reminder that we all share the same atmosphere. A mountain explodes in Indonesia, and a painter in London sees a sky of fire. It connects us, wrapping the planet in a shared shawl of colourful light and cooler air, a global legacy of a local event. We move from the atmospheric effects to the way humanity has learned to live in harmony with this heat. We speak of geothermal energy. In places like Iceland or New Zealand, the volcano is not just a neighbour, it is a provider. The heat that burns deep underground is tapped, brought to the surface to turn turbines and heat homes. Visualize a landscape that is stark and cold, perhaps covered in snow, yet the homes are warm, heated by the water that boils beneath the foundation. See the steam rising from the power plants, clean white clouds against the blue sky. There is no smoke, no burning of carbon, only the harvesting of the Earth's natural thermal budget. It is a symbiotic relationship. We drill down, inviting the heat up, transforming the terror of the magma into the comfort of a lit lamp or a warm radiator. Imagine the water pumping through the pipes of a city, carrying the warmth of the Jurassic era into the living rooms of the present. It represents a truce between human and volcano, a recognition that if we approach with respect and knowledge, the fire that destroys can also be the fire that sustains. Finally, we return to the source of that heat, to one of the most mesmerizing sights in the geological world, the persistent lava lake. Most eruptions are temporary. The lava flows and then stops. But in a few rare places on Earth, like Erta Ali in Ethiopia or Nyiragongo in the Congo, the volcano remains permanently open, a window into the mantle. Visualize standing on the rim of a crater at night. Below you is not a solid floor, but a churning, boiling lake of liquid rock. It is a living surface. Plates of black, cooling crust form on top, floating like dark rafts on the glowing red ocean. As the currents of heat rise from below, these black plates crack and break apart, sinking into the red melt, only to reform again moments later. It is a hypnotic kaleidoscope pattern of creation and destruction, playing out in real time. The sound is a wet, slurping churn, a continuous roar of liquid stone. The light from the lake illuminates the smoke clouds above in a hellish, beautiful red glow. To watch a lava lake is to watch the movement of tectonic plates in miniature, sped up for human eyes. It is the Earth's eye, unblinking and fiery, staring up at the stars, a permanent reminder that beneath the solid ground we trust, everything is fluid, everything is moving, and everything is alive with heat. And where does this fluid rock eventually go? To complete the cycle, we must drift from the fiery lake to the deep, cold trenches of the ocean, to the subduction zone. This is the great recycling centre of the planet. We have spoken of where new land is born, but here, old land goes to die. Visualize the edge of a continent. deep underwater, the heavy floor of the ocean, burdened with millions of years of sediment and the weight of the water, meets the lighter continental rock. It does not crash, it slides quietly, inevitably downward. It bends, diving into the dark, hot throat of the mantle. This is the Blue Trench, a canyon in the ocean floor that creates the deepest places on Earth. As the rock dives, it carries water and history with it. The heat and pressure squeeze the water out, melting the rock above it, creating the very magma that will rise to feed the volcanoes we have explored. It is a perfect, elegant loop. The stone that erupts today was once the ocean floor of an ancient era. Nothing is lost, it is only transformed. Visualize this slow, majestic descent. The old world sinking to become the fuel for the new, a planetary metabolism that ensures the fires never truly go out and the dream of the Earth continues forever. As the old ocean floor completes its long, silent descent into the mantle, melting back into the primal substance of the Earth, a counterbalance must occur. For every ending in the deep geology of our world, there is a beginning. For every destruction, a creation. We drift now away from the crushing depths of the trenches, gliding through the eternal darkness of the abyss until we reach the centre of the ocean basins. Here, we find the longest mountain range on the planet, a feature so vast it wraps around the Earth like the stitching on a baseball, yet it remains almost entirely hidden beneath the waves. This is the mid-ocean ridge. Visualize this immense, jagged spine of rock winding through the Atlantic, the Pacific, and the Indian Oceans. It is a place of perpetual, gentle birth. Here, the tectonic plates are not colliding but drifting apart, pulled open by the rotation of the world. In the gap between them, the rift, magma rises from the mantle to fill the void. It does not explode, it oozes. It is a slow, steady healing of a wound that never closes. Picture the new rock cooling instantly against the seawater, forming fresh crust, adding inches to the width of the ocean floor every year. It is the newest skin of the planet. In the absolute darkness, this ridge radiates a faint warmth, a line of thermal energy that bisects the cold sea. It is the seam of the world, the place where the planet grows, proving that even in the deepest, darkest isolation, the Earth is expanding, renewing, and building itself in the quiet. This pulling apart of the crust does not only happen in the silence of the deep sea. Sometimes it occurs on dry land, tearing continents in slow motion. We travel now to the vast, sun-baked landscapes of East Africa to witness a rift valley. This is a landscape of tension, where the ground is being stretched until it breaks. Visualize a valley that is not carved by a river, but dropped by gravity. The Earth here has pulled apart, and a massive block of crust has sunk down between two parallel fault lines, creating a grand, flat-bottomed corridor bordered by steep, dramatic escarpments. Stand on the edge of this great tear. The air is hot and shimmering. Below, on the valley floor, long, slender lakes glisten. Lake Tanganyika, Lake Malawi. These are the children of the rift, filling the gaps where the Earth has opened. There is a sense of profound scale here. You're looking at the embryonic stage of a new ocean. Given enough millions of years, this valley will widen, the sea will rush in, and the continent will be cleaved in two. But for now, it is a place of dramatic beauty and geological suspense. The volcanoes here are often distinct and strange, erupting unique lavas rich in rare minerals. To look across a rift valley is to see the Earth in the act of separation, a slow, majestic divorce of land masses that creates a cradle for lakes and a corridor for life. While the ridges and rifts mark the edges of the moving plates, there exists a phenomenon that ignores these boundaries, a fire that stays put while the world moves above it. We speak of the hotspot. Deep within the mantle, there is a plume of superheated rock, a stationary blowtorch that rises vertically and burns a hole through the crust. But the crust is not still. The tectonic plate slides over this hotspot like a conveyor belt moving over a candle flame. Visualize this process through the lens of deep time. The hotspot punches through, creating a massive volcano. The volcano grows, breaches the surface of the ocean, and becomes a lush island. But the plate keeps moving, carrying the island away from the heat source. Cut off from its fuel, the volcano goes dormant and eventually extinct, beginning to erode. Meanwhile, directly over the hotspot, a new volcano begins to build. A new island is born behind the first. This is how we get the Hawaiian archipelago, a chain of islands lined up in order of age. Picture the Pacific plate sliding slowly to the northwest, carrying its cargo of stone monuments. It is a geological assembly line. The oldest islands are small and worn far to the west. The newest are tall and fiery, sitting right over the plume. It creates a sense of lineage, a family of islands drifting across the sea, each one a snapshot of where the plate was millions of years ago. As these islands drift away from the warmth of the hotspot, they begin a long, slow journey toward oblivion. We drift now to the lonely open ocean to witness the final stage of a volcanic island, the Guyot. These are the ghosts of mountains. Once they were tall, fire-breathing peaks standing proud above the waves. But time, erosion, and the cooling of the underlying crust have conspired to pull them down. As the island sinks, the waves shave off its summit, flattening it into a tabletop. Eventually it submerges completely, sinking into the cold dark. Visualize a mountain underwater with a perfectly flat top, thousands of feet below the surface. It is a sunken platform, a drowned pedestal. Often, these Guyots are capped with the fossilized remains of ancient coral reefs that tried to keep up with the sinking but failed. They stand in the silent currents, providing a gathering place for deep-sea fish, a localized ecosystem in the void. There is a melancholy majesty to a Guyot. It is a reminder of the impermanence of land. It teaches us that even the mightiest mountains eventually return to the sea, bowing their heads beneath the waves to become silent, flat-topped monuments to the past. But before an island can die, it must be born. Let us rewind the clock and witness the violent steaming birth of land in a phenomenon known as a Surtsean eruption. This occurs when a volcano erupting in shallow water finally breaks the surface. The conflict between the magma, 2000 degrees Fahrenheit, and the ocean water, near freezing, creates explosions of steam and ash that look like the feathers of a giant rooster tail. Visualize the grey, churning Atlantic Ocean off the coast of Iceland. Suddenly the water begins to boil. A column of black ash and white steam blasts miles into the sky. The sea is turning into land before your eyes. It is a chaotic, noisy birth. Lightning flashes in the ash cloud. Bombs of lava hiss as they hit the water. Slowly a black cone of tephra rises above the waves. It is fragile at first, easily washed away by storms, but the fire persists. Eventually lava flows over the loose ash, capping it with hard rock, cementing the island's existence. Picture the steam clearing to reveal a brand new piece of earth, steaming and black, untouched by any footstep. It is the world in its first day of creation. It is a raw, elemental victory of fire over water, a solitary fortress of solitude rising from the whitecaps. On the opposite end of the spectrum from these explosive, watery births is the slow, viscous extrusion known as a lava dome. Sometimes the magma that rises is not runny and fluid, but thick, sticky and pasty, rich in silica. It cannot flow. Instead, it squeezes out of the vent like toothpaste from a tube, piling up over the opening. Visualize a large crater, and within it, a mound of grey, jagged rock that seems to be growing from the inside out. This is the dome. It expands as fresh magma is injected into its core, swelling like a blister. The surface is rough, covered in sharp spines and blocks of rock. By day, it looks like a pile of rubble, but by night, the truth is revealed. The cracks between the rocks glow with a dull, menacing red light. You can hear the sound of rocks tumbling down the sides as the dome shifts and grows. It is a plug in the throat of the volcano, capping the pressure. There is a tension in looking at a lava dome, a sense of pent-up energy. a slow-motion expansion that feels heavy and deliberate. It is the volcano holding its breath, building a fortress of stone over its own vent, a glowing heart encased in a shell of grey armour. On the flanks of these larger volcanoes, or sometimes along the cracks of a rift, we find smaller, more intimate vents known as spattercones. These are the personal-sized volcanoes of the geological world. They are formed when lava is ejected in small, sticky clots that fall right back around the vent, welding themselves together while still hot. Visualize a landscape of black rock, and rising from it, a steep-sided chimney, perhaps only 10 or 20 feet tall. It looks like a Gothic tower made of dripping wax. Standing near one, you can hear the wet, rhythmic sounds of the earth coughing. Whoomp, splash, whoomp. The blobs of lava fly up a few feet and land with a sticky slap on the rim, building the walls higher and steeper with every cough. The rock here is often colourful. Iridescent blues, deep purples, and rusty reds caused by the oxidation of the iron while it was still hot. It feels almost biological, like a termite mound made of fire. These spattercones are the playful side of volcanism, small fountains that build their own monuments, distinct and sculptural, standing as lonely sentinels on the lava plains. Closely related to the spattercone but with a different mechanism is the hornito. The word means little oven in Spanish. These are rootless vents. They do not connect directly to the magma chamber deep below. Instead, they sit on top of a flowing lava tube. When the pressure in the tube gets too high, or steam needs to escape, the lava is forced up through a crack in the roof of the tube. Visualize a field of smooth, ropey lava. Scattered across it are small, hollow pinnacles of rock glowing from the inside. They are like chimneys on a rooftop, venting the heat of the house below. A hornito is gentle. It does not roar. It puffs and sighs, releasing gas and small spatters of molten rock. At night they look like jack-o'-lanterns, jagged faces of rock illuminated by the orange candle flicker of the lava flowing beneath them. They are temporary structures, fragile and hollow. To peer into a hornito is to look through a keyhole into the flowing river of fire beneath your feet, a glimpse of the hidden energy that moves beneath the solid crust. Sometimes the lava flows through a forest, creating one of the most haunting and beautiful formations in nature, the lava tree. When a fluid flow moves through a grove of trees, the level of the lava might rise several feet surrounding the trunks. The wet wood of the tree cools the lava touching it, creating a hard shell of rock around the bark. The heat eventually incinerates the tree inside, turning it to ash, and the rest of the lava flow drains away. What is left behind is a stone ghost. Visualize a forest floor made of black rock studded with vertical pillars. These are the moulds of the trees that once stood there. They are hollow tubes of stone standing exactly where the trees stood, preserving the texture of the bark on the inner walls. Some of them stand tall, others are fallen logs of stone. It is a petrified memory of a forest. Walking through a landscape of lava trees feels sacred and eerie. You're walking in a negative space, where the life has been replaced by stone, yet the shape of the life remains perfectly preserved. It is a sculpture garden created by destruction, a permanent record of a single moment when the forest met the fire. Finally, we travel to the edge of the sea, to the place where the lava meets the waves and is ground down by time. We have walked on black sand, but there is something even rarer and more gem-like, the green sand beach. This phenomenon occurs when the lava is rich in a mineral called olivine. Olivine is a heavy green crystal that forms early in the cooling process. It is the gemstone peridot. Visualize a cove carved into a volcanic cliff. The waves here are not crashing on beige or white sand. The beach glistens with a surreal olive-green hue. As the waves wash away the lighter ash and black sand, the heavier green crystals are left behind, concentrating on the shore. Pick up a handful of this sand. It is like holding thousands of tiny emeralds. They are cool, smooth, and translucent, catching the sunlight. The contrast of the green sand against the dark black lava rocks and the deep blue ocean is visually stunning. It feels like a treasure trove, a beach made of crushed jewels. It is a reminder of the hidden beauty inside the dark magma. The volcano does not just spew grey ash and black rock, it carries the components of gems hidden deep within, waiting for the ocean to wash away the darkness and reveal the green, sparkling heart of the stone. As the sun sets over this emerald beach, casting long shadows across the crystals, we allow the image of the sparkling green sand to fade into the soft velvet darkness of our resting mind. The rhythm of the waves washing over the gems becomes the rhythm of your breath, steady, slow, and precious. We drift away from the shore, floating back into the safe, weightless embrace of the void, ready to continue our journey through the wonders of the dreaming earth. From the glistening jewel-like shores of the green olivine beach, we step further along the coastline, where the sand transforms yet again, darkening into the deepest shade imaginable. We find ourselves walking upon a stretch of black sand. This is the shattered memory of basalt, the most common volcanic rock, ground down by the ceaseless patience of the tides. Visualize a beach that absorbs the light rather than reflecting it. It is a ribbon of midnight stretching between the white foam of the waves and the green of the jungle. Because of its colour, this sand holds a secret warmth. Even as the sun begins to set and the air grows cool, the black grains beneath your feet retain the memory of the day's heat. Imagine burying your toes into this warmth, feeling the coarse, heavy texture of the grains. They're heavier than ordinary sand, dense with iron and magnesium. There is a grounding sensation here, a feeling of connection to the heavy magnetic heart of the planet. To lie upon a black sand beach is to be cradled by the cooled lava, held in a warm embrace that persists long into the twilight. It is a landscape of high contrast. The stark black ground, the brilliant blue water, the white spray. A place where the visual world is simplified into its most elemental colours, calming the mind with its bold, simple beauty. Tracing the origin of this black sand, we must turn our eyes back toward the source, to the fresh flows that spill from the vent. Not all lava moves in the same way. It has moods and textures. We drift first to the smooth, hypnotic flow known by its Hawaiian name, pahoho. This is the fluid, high-temperature lava that moves with the grace of thick syrup or molten chocolate. It flows quietly, forming a skin that stretches and twists as the liquid rock moves beneath it. Visualize the texture of pahoho as it cools. It does not break, it folds. It creates shapes that look like coils of heavy rope, billowing clouds, or folds of satin fabric draped over the earth. It is a sculpture in motion. The surface is often iridescent, shining with a metallic blue or silver sheen as it oxidizes. Imagine watching a toe of this lava inch forward. It advances slowly, bulbous and smooth, glowing bright orange at the leading edge before the grey skin forms over it, only to break open again a moment later to release a new toe. It is a mesmerizing, silent creep. When it hardens, it creates a landscape that is smooth and undulating, inviting you to walk across its billows. It is the earth expressing itself in curves, a testament to the fluid grace of stone when it is hot enough to dream. But the mood of the volcano can change, and with it, the texture of the stone. When the lava cools slightly and becomes thicker, or flows more violently, it transforms into air. This is the rough, jagged counterpart to the smooth pahoho. It is a tumbled mass of sharp, clinker-like rocks, a chaotic river of broken stone that carries a red-hot core beneath. Visualize the sound of an air flow. Unlike the silence of the smooth lava, this flow sings a song of friction. As the jagged blocks tumble over one another, they create a sound like breaking glass or falling pottery. Clink, chink, crackle. It is the sound of the earth grinding its teeth. The visual is one of raw, jagged power. The rocks are sharp, spiny, and difficult to traverse, glowing with a dull, menacing red in the crevices. Steam rises from the gaps. It represents the friction of the world, the resistance of the cooling rock against the urge to move. Yet, even in this sharpness, there is beauty. The way the light catches the myriad facets of the broken stone makes the flow glitter in the night, a river of dark diamonds and embers rolling slowly down the mountain, creating a barrier that protects the solitude of the high peaks. Deep within these flows, and indeed deep within the magma chamber itself, lies a vital component that is not rock at all, but something far more familiar to our existence. We speak of volcanic water vapour. It is a profound truth that much of the water in our oceans and the air in our atmosphere was originally trapped inside the rock of the mantle, released over billions of years by volcanic outgassing. The volcano is the great exhaler of the sky. Visualize a massive eruption, not as a disaster, but as a cloud-making machine. The billowing white plumes that rise from a volcano are mostly steam, water that has been liberated from the crushing pressure of the deep earth. As this steam rises, it cools and condenses, falling as rain. Imagine the very first rains of the primordial earth, storms that lasted for centuries, born from the breath of 1,000 volcanoes. This water filled the basins of the world, creating the oceans we know. When you drink a glass of water or feel the rain on your skin, you are touching the ancient exhalation of the volcanoes. They are the hydration of the planet, the original source of the clouds that drift through your dreams, knitting the fire below to the water above in a cycle that sustains all life. Sometimes the magma does not erupt to the surface to release this steam. Instead, it rises and stalls, trapped deep within the crust, where it cools over millions of years in total darkness. This process creates the majestic formations known as batholiths. These are the hearts of volcanoes that never were, vast chambers of magma that solidified underground to form granite. Visualize the Sierra Nevada mountains, or the towering cliffs of Yosemite. These are not piles of lava, they are exposed batholiths. The magma cooled so slowly, over tens of thousands of years, that the crystals within it had time to grow large and strong, interlocking to form the speckled grey and white stone we call granite. Then, the softer earth above was washed away by wind and time, revealing this hardened core. To look at a granite cliff is to look at the frozen interior of the earth. It is a monument to patience. The stone feels cool and solid, humming with a stability that feels eternal. These are the anchors of the continents, the massive buoyant rafts of rock that allow the land to rise above the sea. They remind us that some of the greatest things are achieved in the quiet dark, waiting eons for their moment to be revealed to the sun. Within these cooling bodies of rock, or in the gas bubbles trapped in ancient lava flows, nature hides its most beautiful secrets. We drift to the concept of the geode. When a bubble of gas is trapped in cooling lava, it leaves a hollow cavity. Over millions of years, mineral-rich water seeps through the porous rock, entering this dark little room. Drop by drop, it deposits crystals on the walls of the cavity. Visualize a rough, round rock, undistinguished and plain, sitting in the mud. It looks like a potato made of stone. But crack it open, and you reveal a dazzling cathedral of amethyst, citrine, or clear quartz. The interior is lined with sharp, perfect geometric points that sparkle with an inner light. It is a private universe of beauty, created in the dark, intended for no eyes to see. The contrast between the rough grey exterior and the sparkling violet interior is a lesson in inner worth. The volcano creates the shell, but time and water create the jewel. Imagine shrinking down to stand inside a giant geode, surrounded by towering spires of purple crystal, bathed in a soft, refracted light. It is a cave of silence and perfection, a hidden sanctuary protected by the hard armour of the volcanic stone. From the hidden jewels of the land, we return to the ocean to witness a different kind of chimney, one that does not smoke with black soot, but glows with a ghostly white. We drift to the alkaline vents, often called the white smokers. Unlike the black smokers that roar with the heat of magma, these vents are gentler, cooler, and taller. They are formed by a chemical reaction between the seawater and the mantle rock, creating towering spires of white limestone and brucite that look like sunken cathedrals or wax castles. Visualize the lost city field in the Atlantic. Spires of white rock rise hundreds of feet from the dark ocean floor, ghostly and pale in the beam of a submersible's light. They shimmer with fluids that are warm, alkaline, and rich in hydrogen. These structures are delicate, lace-like in their intricacy. They look like ancient ruins of a civilization that never existed. In the pores of these white towers, scientists believe life on Earth might have truly begun. Microscopic life cradled in the warm, safe, chemical-rich labyrinth of the stone. Floating near them, you feel a sense of reverence for this cradle of existence. It is a quiet, white city in the eternal night, bubbling softly, building its towers atom by atom, a testament to the gentle side of the Earth's internal chemistry. Rising from the depths back to the towering peaks, we turn our attention to the interplay of light and mountain at the break of day. We witness the phenomenon of the volcanic shadow. Because stratovolcanoes are often perfect cones rising from flat landscapes or oceans, they cast shadows that are geometrically perfect, stretching for hundreds of miles at sunrise or sunset. Visualize standing on the summit of Mount Tide or Mauna Kea as the sun begins to rise. You're above the clouds. As the golden light hits the peak, a perfect triangular shadow is cast onto the atmosphere itself. It looks like a dark pyramid stretching endlessly toward the horizon, a phantom mountain projected onto the sky. The shadow is deep blue and violet, contrasting with the pink and orange of the dawn. It is a moment where the solid earth imposes its shape upon the air. As the sun rises higher, the shadow retreats, shrinking back into the mountain. It is a fleeting daily spectacle, a reminder of the sheer dominance of the volcano over its environment, blocking out the sun itself to paint its own portrait on the canvas of the west. Sometimes, the influence of the volcano on the sky lasts far longer than a sunrise. We drift to the quiet, melancholy beauty of the volcanic winter. When a colossal eruption throws enough sulfur and ash into the stratosphere, it reflects the sun's warmth back into space, lowering the global temperature. While this can be challenging for life, in our dreamscape we focus on the stillness it brings. Visualize the year 1816, the year without a summer following the eruption of Mount Tambora. A hush fell over the world. Snow fell in June. The light was pale and diffused, casting a silver sheen over the meadows. The sunsets were famously brilliant, but the days were wrapped in a cool, misty blanket. There is a deep, muffled silence in a world cooled by volcanic veil. It is a time of hibernation, a pause in the frantic energy of growth. The earth pulls the covers up tight. The air is crisp and clean. It reminds us of the interconnectedness of all things, how a fire on an island in Indonesia can bring a quiet, snowy morning to a farmhouse in New England. It is a global cooling breath, a temporary return to a quieter, slower state of being. Finally, we look at the very first stirrings of life that return after the fire has cooled. We drift to the concept of primary succession. When a lava flow solidifies, it is a barren, sterile landscape of black rock. No soil, no water, no life. It seems like a desert of stone, but the wind carries tiny spores, and soon the rock begins to change colour. Visualize the arrival of the lichen. It is not a plant, but a partnership between fungus and algae. It appears as small, circular patches on the rough basalt, silvery grey, vibrant orange, or pale green. It grows incredibly slowly, expanding by millimetres over decades. But as it grows, it eats the rock. It dissolves the stone with weak acids, breaking it down, grain by grain, to create the very first pinch of dust that will become soil. It is the pioneer of the new world. Picture a field of black lava slowly being painted with these splashes of colour, a natural mosaic forming over centuries. It is a slow, silent victory of softness over hardness. The lichen prepares the way for the moss, which prepares the way for the fern, which prepares the way for the forest. It teaches us that even in the most desolate, hardened places, life will find a foothold, starting small, working slowly, and eventually turning the barren rock into a garden. From the microscopic, silent labour of the lichen, dissolving the rock grain by grain, we witness the arrival of a larger, more graceful form of life. The black canvas of the lava field, prepared by the fungi and the mosses, is now ready to receive the hapu'u fern. Visualize the slow, prehistoric unfurling of these great plants. In the volcanic islands of the Pacific, they are the first true giants to return, rising from the cracks in the basalt where moisture is gathered. Picture a fiddlehead, the spiraled green tip of the young fern, tightly coiled like a spring of potential energy. It is covered in soft golden brown hairs that catch the morning mist, glistening like dew-covered velvet. As the days pass, this spiral slowly unwinds, stretching outward and upward to become a massive arching frond. The contrast is visually arresting, the brilliant emerald green of the leaves against the stark charcoal black of the volcanic ground. These ferns create a canopy, a shaded room beneath their leaves where the air is cool and damp. Walking through a forest of them feels like stepping back into the Jurassic era. There is a stillness here, a sense that the world is young again. The air smells of wet earth and crushed greens. It is a soft, leafy architecture built upon a foundation of fire, reminding us that nature's desire is always to cover the hard edges with softness, to turn the barren stone into a garden of waving green lace. Within this emerging garden, amidst the silence of the stones and the ferns, a very specific and tiny creature makes its home. We drift our focus down to the cracks in the cooled lava flow to find the lava cricket. This is a life form that does not flee the desolation, but seeks it. In the first few months after an eruption, when the landscape is nothing but cooling cinders and wind, this small wingless cricket appears, a pioneer of the animal kingdom. Visualize this tiny being, dark as the rock itself, moving with deliberate caution across the glass-sharp edges of the AA flow. It lives in a world of silence, for it has no wings to chirp with. It is a creature of the quiet. It survives by scavenging the organic debris, bits of leaves, sea foam, insects, that the wind blows onto the barren lava. It thrives in the residual heat, finding comfort in the warmth that still radiates from the Earth's core. Imagine the resilience of such a small heart beating against the vast empty backdrop of a volcanic plain. It is a secret keeper, hiding deep in the fissures during the heat of the day, emerging under the starlight to forage. It reminds us that there is no place on Earth too harsh for life to find a foothold, that even in the scorched aftermath there is a pulse, quiet and determined, moving through the dark. From the tropical heat of the lava cricket's home, we transport our spirits to the uttermost south of the world, to the frozen continent of Antarctica. Here, amidst the eternal ice, stands Mount Erebus, the southernmost active volcano on Earth. It is a paradox of fire and ice. On the flanks of this white giant, the heat escaping from the magma chamber creates one of the most surreal structures in nature, the ice fumarole. Visualize a tower of ice standing 10 or 20 feet tall, rising from the snowy slope like a chimney. These are formed when the warm volcanic steam rises from the ground and instantly freezes upon hitting the polar air, building up layer by layer into a hollow spire. But the true magic lies inside. If you were to peer into one of these towers or crawl into the caves beneath them, you would enter a world of blue light. The steam carves out intricate caverns within the glacier, rooms of polished ice that glow with a sapphire luminescence filtering down from the surface. Inside it is warm and humid, a tropical microclimate hidden inside a shell of ice. It is a sanctuary of comfort in a landscape of blizzard. Visualize the steam swirling softly in the blue light, the sound of dripping water echoing in the silence. It is a womb of warmth, protected by the cold, a secret room where the volcano's breath creates a safe haven against the wind. We drift from the blue light of the ice caves to a different kind of blue illumination, one born of combustion and chemistry. We travel to the crater of Kawah Ijen in Indonesia, to witness the phenomenon of the blue fire. This is not the orange glow of lava, but the combustion of high-pressure sulfuric gases. When these gases escape from the cracks in the volcano at high temperatures, they ignite upon contact with the air, burning with an electric neon blue flame. Visualize this spectacle at night. It looks as though the mountain is bleeding liquid light. The blue flames can reach nearly 20 feet high, flowing down the rocky slopes like a river of spilled starlight. It is a scene from a fantasy, ethereal and ghostly. The colour is intense, a saturated violet blue that seems to hum with energy. It is beautiful, yet it signals the presence of intense chemical power. The smoke that rises is thick with sulphur, but in our dream, we are safe from the scent. We see only the mesmerizing dance of the indigo fire. It flows and cascades, a waterfall of flame that defies our expectations of what fire should look like. It is the earth dreaming in technicolor, painting the dark canvas of the crater with strokes of electric brilliance, a reminder that the palette of the planet is far richer than we know. From the vivid electric blue, we soften the palette to something pastel, warm and inviting. We drift to the shores where volcanic islands are ringed by pink sand beaches. While we have walked on black and green sand, the pink sand is a collaboration between the volcano and the life it supports. In the warm, shallow waters surrounding a dormant volcanic island, coral reefs thrive on the submerged basalt foundation. A tiny organism called a foraminifera lives there, growing a shell of reddish-pink calcium carbonate. Visualize the gentle waves crushing these red shells over millennia, mixing them with the white calcium of clams and the remnants of the reef. The result is a sand of soft, blushing rose. Picture walking on this beach at sunset. The low golden light of the sun enhances the pink hue, turning the shoreline into a ribbon of cotton candy stretching against the turquoise sea. The sand is cool and powdery soft between your toes. It is a landscape of romance and gentleness. The anger of the ancient volcano that built the island is long forgotten, replaced by the soft, rhythmic washing of the tide against the rosy shore. It is a place of absolute calm, where the hard geology has been completely softened by the sea, leaving behind a margin of colour that feels like a physical sigh of relief. The soil that sits above these beaches, on the slopes of the sleeping volcanoes, possesses a richness that flavours the very culture of humanity. We drift to the concept of volcanic terroir. Farmers and vintners have known for centuries that the earth on the side of a volcano is unlike any other. It is filled with ash, pumice, and minerals that provide perfect drainage and unique nutrition to the roots of plants. Visualize a vineyard on the slopes of Mount Etna or Vesuvius. The vines are old, their gnarled roots twisting deep into the dark, rocky soil. They are drinking from the history of the mountain. The grapes that grow here are small, concentrated, and bursting with flavour. When you taste the wine or the coffee grown in the volcanic highlands of Ethiopia or Hawaii, you are tasting the volcano itself. There is a flintiness, a mineral depth, a struck match quality that speaks of the fire below. Visualize the sun warming the dark leaves of the coffee plant, the berries ripening slowly in the mist. It is a transformation of geology into sensory pleasure. The volcano does not just create land, it seasons it. It infuses the bounty of the earth with a complexity that can be tasted, a connection between the deep magma and the fruit of the vine that nourishes the spirit. Deep within the flows that create this soil, there are sometimes rocks that do not belong, travellers from a realm we can never visit. We speak of the xenolith, a word that translates to foreign rock. These are chunks of the deep mantle, the layer of the earth below the crust, that were ripped loose by the rising magma and carried to the surface intact, like passengers on a fiery elevator. Visualize a dark grey boulder of basalt. Embedded in its centre, standing out like a beacon, is a cluster of bright lime green crystals. This is peridotite, the actual stuff of the mantle. It is a rock that was never meant to see the sun. It belongs miles beneath our feet, under crushing pressure. Yet here it sits, encased in the lava that carried it, a green jewel in a dark setting. Touching a xenolith is the closest we can come to touching the core of our planet. It feels heavy, dense, and alien. It is a message from the deep, a sample of the inner world delivered to the outer world. It reminds us that beneath the familiar crust we walk upon, there is a vibrant, colourful, crystal-filled world that we are separated from only by the thin skin of the tectonic plates. While the xenolith is heavy and dense, the volcano also crafts a stone that is the very definition of weightlessness. We drift to the delicate structure of reticulite. This is the rarest and most fragile of volcanic rocks, formed when a froth of lava is thrown into the air and the bubble walls burst, leaving behind only the connecting struts. It is a honeycomb of glass. Visualize holding a piece of reticulite in your palm. It is a golden brown lattice, incredibly intricate, like a sponge made of spun sugar. It is 98% air. It is so light that if you toss it, it doesn't land. It drifts. It looks like a solidified foam, a freeze frame of the moment gas tried to escape liquid rock. It is nature's filigree work. You must handle it with extreme care, for the slightest pressure will crush it to dust. It represents the ephemeral nature of the eruption, a structure built almost entirely of nothingness, held together by the memory of fire. It is a rock that challenges our understanding of stone, proving that Earth can be as airy and delicate as a cloud. From the fragile and airy, we move to the heavy and eternal. We visit the ancient forests that were silenced by the volcano, only to be granted a form of immortality. We speak of the petrified forest. Eons ago, a volcanic explosion blanketed a lush forest in thick, heavy ash. The trees did not burn. They were buried instantly, cut off from oxygen, halting their decay. Over millions of years, groundwater rich in silica from the volcanic ash seeped into the wood. Atom by atom, the wood was replaced by stone. Visualize a great log lying in the painted desert. It looks like an old, fallen pine tree, the texture of the bark rough and distinct. But when you touch it, it is cold and hard as quartz. It is polished like a gem. The rings of the tree are still visible, preserved in bands of agate, jasper, and amethyst. It is a tree turned to jewel. The colours are brilliant reds, yellows, and deep purples. This is the volcano as a preservationist. It stopped time for these trees, translating their organic life into a mineral existence that will last forever. Walking among them, you feel a heavy, quiet reverence. These are the ancestors of the forest, sleeping in stone, beautiful and unbroken by the passage of ages. Finally, we feel the earth moving beneath us, not with the violence of an eruption, but with a slow, deep breath of recovery. We drift to the concept of isostatic rebound. This is the Earth's memory of weight. In places like Iceland, where volcanoes live beneath heavy glaciers, the crust is pushed down by the immense weight of the ice. It bows and sinks into the mantle, like a mattress under a sleeper. But as the ice melts, or as the volcanic material shifts, the crust begins to rise back up. This is not a fast movement, it is a geological inhale. Visualize the land slowly lifting out of the sea, inch by inch, year by year. Old beaches are lifted high onto the cliffs, becoming terraces of dry land. It is the buoyancy of the tectonic plate asserting itself. There is a sense of balance here, a reminder that the Earth is elastic and responsive. It is not a dead, static rock, but a floating raft that adjusts to every burden it carries. Feel this slow, uplifting sensation in your own body, a gentle rising, a lightening of the load, as if gravity has momentarily lost its grip, allowing you and the Earth to float upward into a state of perfect, weightless equilibrium. That gentle, buoyant rising of the Earth, floating back to equilibrium after the weight of the ice has vanished, reminds us that the ground is not a static stage, but a landscape of constant adjustment and flow. Sometimes, this flow of rock moves around obstacles rather than over them, creating one of the most poetic sanctuaries in the volcanic world, the Kipuka. This is a Hawaiian word for an island of land, not an island in the water, but an island of ancient green forests surrounded on all sides by a sea of black solidified lava. Visualize a massive eruption where the river of fire flows down the mountainside. It divides, branching like a stream, flowing around a high hill or a mound of older earth, leaving that small patch of land untouched. As the lava cools into a desolate black plain, this green oasis remains. Picture standing inside a kipuka. It is a time capsule. Outside the circle of green, the world is barren, sharp and silent, a moonscape of dark stone. But step inside the boundary of the trees and you are enveloped in the song of birds, the rustle of ferns, and the scent of damp, rich soil. It is a biological ark, a refuge where the forest waits patiently. From these green islands, life will eventually spread out again to recolonize the black desert. It is a profound image of protection, a reminder that even when the world seems consumed by fire, there are pockets of safety, small gardens of continuity that the lava respects and preserves. From the safety of the green island, we venture out onto the hardened roof of the lava flow itself. While the surface is cool and solid, beneath our feet, the river of fire may still be rushing toward the sea. Occasionally, the roof of this underground tunnel collapses, creating a window into the inferno known as a skylight. Visualize walking across the dark, undulating crust at twilight. In the distance, you see a soft orange glow emanating from a hole in the ground. As you approach the edge and look down, the heat hits your face dry and intense. Through this portal, you can see the magma moving, a thick, radiant orange liquid sliding silently through the tube. It flows with a mesmerizing smoothness, faster than you might expect, carrying the energy of the mountain deep underground. Seeing a skylight is like looking through a keyhole into the veins of the planet. Above, the stars are cold and distant. Below, the earth is alive and glowing. The contrast is hypnotic. The cool, solid ground you stand on, and the molten river just a few feet below, separated only by a thin arch of stone. It is a secret glimpse of the hidden power that moves beneath the surface of our world. Sometimes, the volcano releases its energy not as a flowing river, but as a playful, geometric breath of air. We look up from the glowing pit to the crater rim to witness the rare and whimsical phenomenon of the volcanic vortex ring. This occurs when a sudden short burst of gas is expelled from a narrow vent, similar to a puff of smoke from a cannon. Visualize a perfect circle of white steam and grey ash spinning through the blue sky. It is a smoke ring on a gargantuan scale, perhaps hundreds of feet across. It holds its shape remarkably well, spinning internally, a toroidal donut of cloud drifting lazily upward. It looks unnatural in its perfection, a precise geometric form amidst the chaos of the eruption. Watch it float higher and higher, maintaining its integrity against the wind, a silent halo sent from the underworld. It is a moment of gentleness, a smoke signal that speaks of the fluid dynamics of the air. Eventually the ring begins to wobble, fraying at the edges until it dissolves back into the formless mist of the atmosphere. It is a fleeting masterpiece of physics, a reminder that nature delights in creating order and shape even in its exhalations. As the smoke ring dissolves into the air, we lower our gaze back to the surface of the lava flow, where the pressure of the liquid rock tries to push upward against the cooling crust. This struggle creates the formation known as a tumulus. These are earth blisters, mounds of solid rock that have been pushed up from below like a rising loaf of bread. Visualize a field of smooth pahoho lava. Here and there the ground swells into a dome-shaped mound, perhaps the size of a small house. The pressure from the still-flowing lava beneath has forced the hardening crust to arch upward. Often, the top of the tumulus is cracked open, a jagged fissure running down its spine where the rock could stretch no further. Through this crack you might see the squeeze out of a little more lava, like the filling of a pastry. These mounds give the landscape a rolling organic texture. They are the frozen evidence of the expansion and pressure that exists, even as the rock is turning to stone. Running your hand over the cracked summit of a tumulus, you feel the history of that upward push, the moment the Earth tried to grow just a little bit taller before freezing in place forever. The flow of lava continues its journey, moving past the tumuli, past the skylights, until it reaches the final boundary, the ocean. Here, where the fire meets the water, a unique and dramatic atmospheric condition is born. We call it laze, a blending of the words lava and haze. This is not the volcanic smog of the summit. This is a white, billowy plume of steam, hydrochloric acid, and tiny glass particles created by the chemical shock of the boiling sea. Visualize the edge of the land where the molten rock pours into the surf. The sound is a chaotic symphony. The deep rumble of the lava, the hiss of the steam, and the crashing of the waves. The plume that rises is blindingly white, dense and tumbling. It drifts along the coastline carrying a scent that is distinct and sharp, a mixture of sulfur, brine, and heat. It is the smell of the earth being forged. Within this cloud, the water is fighting the fire, and the fire is turning into land. The laze plume softens the light, creating a misty, dreamlike environment where the ocean appears to be boiling. It is a place of elemental transformation, where the liquid ocean and the liquid earth collide to create the solid ground and the vaporous sky. Inside the towering clouds of steam and ash that rise from an eruption, moisture and dust dance together to create a tiny, peculiar form of precipitation known as accretionary lapilli. These are, in essence, volcanic hailstones, but instead of ice, they are made of mud. Visualize the inside of an ash cloud. It is swirling with fine grey dust. As water vapour condenses or rain falls through this cloud, the droplets catch the ash particles. As they tumble through the turbulence, they gather more and more layers of ash, rolling up like tiny snowballs. When they finally fall to the ground, they land not as loose dust, but as small, perfectly spherical pellets. Imagine holding a handful of these little mud balls. They are the size of peas, grey and concentric. If you cut one open, you would see the layers like an onion. They are the result of the atmosphere trying to clean itself, scrubbing the ash from the air and binding it into these small, tangible beads. It is a texture unique to the volcano, a rain of earth, created by the marriage of the storm and the stone. Beneath the surface layers where these pellets fall, the earth is often torn apart by the immense pressure of the rising magma. But nature abhors a vacuum, and these cracks are instantly filled with molten rock that hardens to form dikes. These are the vertical sheets of stone that act as the ribs of a volcano. Visualize a cross-section of a mountain. Cutting through the horizontal layers of ash and old flows are these vertical walls of rock, standing straight and tall. They are the frozen pathways of magma that never reach the surface, the plumbing system of the eruption. Over millions of years, as the softer surrounding rock erodes away, these dikes are left standing as dramatic, wall-like ridges running across the landscape. They look like man-made fortifications, great walls of stone built by giants. Some radiate out from the centre of the volcano like the spokes of a wheel. Others run parallel in great swarms. Touching the face of a dike, you are touching the crystallised ambition of the magma, the path it carved for itself through the solid crust. They represent the strength and structural integrity of the mountain, the hardened will of the fire to ascend. Sometimes, the fire does not ascend in a single channel, but collapses in a catastrophic flow of superheated ash and gas that floods the landscape like a liquid avalanche. When this material settles and cools, it welds itself together into a massive solid sheet of rock known as an ignimbrite. The name comes from the Latin for fire, rain, rock. Visualize a vast, high plateau, flat as a table, stretching to the horizon. The rock beneath your feet is pinkish grey, hard as concrete, and rings like a bell when struck. This entire landscape was deposited in a single afternoon. The ash was so hot when it landed, over 1,000 degrees, that the glass shards within it melted back together, welding into a solid mass. If you look closely at the rock, you can see flattened streaks of black glass, called fiamme, or flames, which are the squashed remains of pumice stones. Ignimbrites are the monuments of the Earth's greatest exhales. They smooth over the ancient topography, burying valleys and hills under a blanket of burning stone that turns into a permanent flat horizon. It is a landscape of silence and uniformity, a vast, hard floor laid down by the sky. To understand where this heat originates, we must push our consciousness deeper, past the crust, past the solid rock, into the layer that allows the continents to drift. We descend into the asthenosphere. This is the region of the upper mantle that sits below the rigid plates. It is not quite liquid, but it is not quite solid. It exists in a state of ductility, like warm taffy or soft plastic. Visualize this deep, dark layer of the Earth. It yields, it flows. It is the lubricating oil of the planetary machine. Because the rock here is soft and malleable, the hard tectonic plates can slide across it, carrying the oceans and the mountains with them. Feel the slow, viscous movement of this layer, a flow that is measured in inches per century. It is a sensation of immense patient power. It is the reason the Earth is dynamic. If the asthenosphere were solid, the world would be locked in place, dead and still. But because it yields, the world moves. It is the deep, soft subconscious of the planet, the hidden fluidity that permits the surface to change and grow. As the plates slide over this slippery layer, spreading apart at the ocean ridges, they record a secret history of the Earth's magnetic soul. We drift to the concept of magnetic striping. The Earth is a giant magnet, but its polarity is not constant. Every few 100,000 years, the north and south poles flip places. The lava that erupts at the mid-ocean ridges contains iron minerals that act like tiny compass needles. As the lava cools, these minerals lock in place, pointing to wherever north was at that moment. Visualize the floor of the Atlantic Ocean as a giant tape recorder. As the sea floor spreads, it creates parallel bands of rock. One band has minerals pointing north, the next, formed 1 million years later, has minerals pointing south. This pattern creates invisible stripes across the ocean floor, a barcode of planetary history. We cannot see it with our eyes, but to the magnetic sense, the ocean floor is a striped zebra of energy. It is a record of the heartbeat of the Earth's core, preserved in stone. Imagine gliding over these invisible stripes, reading the history of the magnetic reversals, knowing that the solid rock holds the memory of the time when the compass pointed south. It is the silent magnetic rhythm of the world, written in the stone of the deep sea. Reading the magnetic barcode on the ocean floor, we begin to understand that the Earth is constantly rewriting its own map, a slow, majestic shifting of positions that occurs in the silence of the deep. As the ocean floor moves, carrying the islands away from the heat source that birthed them, the great volcanoes begin to sink. They bow their heads to the weight of time and gravity, descending millimetre by millimetre back into the sea. But in the tropical waters, where the sun is warm and the light is clear, life refuses to let the mountain disappear completely. We drift now to the formation of the atoll. Visualize a ring of brilliant turquoise water in the middle of the deep indigo ocean. There is no central island, no mountain peak piercing the clouds. There is only a perfect circle of white sand and green palms enclosing a calm, shallow lagoon. This is the halo of the volcano. As the volcanic island slowly sank beneath the waves, the coral reef that lived on its shores kept growing upward, reaching for the sunlight. The stone went down, but the life went up. What remains is a ghost of the island's perimeter, a living monument to the shape of the coastline that used to be. Picture yourself floating in the centre of the lagoon. The water is impossibly clear, shimmering with the reflection of the clouds. It is a sanctuary of stillness, protected from the rough ocean swells by the ring of coral. Beneath you, the original peak of the volcano lies buried under thousands of feet of limestone and water, sleeping in the dark. But up here, in the light, the atoll forms a bracelet of life, a quiet, circular embrace that marks the grave of the fire with a garden of the sea. It is a testament to persistence, a reminder that even as the land fades, the beauty it supported can remain, holding its shape against the open sea. Drifting from the coral ring toward the active shores where lava still meets the water, we encounter a phenomenon that is as delicate as the atoll is enduring. We have spoken of the heavy rocks and the sharp glass, but the volcano also creates something thin, translucent and waving in the currents. We speak of limu o pele, or Pele's seaweed. This occurs during a submarine eruption or when lava enters the sea. As the water boils and steam expands violently inside the molten rock, it blows large bubbles of lava. When these bubbles burst, they shatter into thin, curved flakes of brownish-green glass. Visualize these fragments drifting underwater. They look exactly like sheets of seaweed or wax paper, thin enough to be translucent. They are fragile, undulating in the surge of the waves before settling on the ocean floor. Imagine holding a piece of this volcanic seaweed. It is not wet vegetable matter. It is stone stretched to its absolute limit. It is crisp and brittle, snapping with a delicate sound. To see a beach covered in limu o pele is to see a shoreline glittering with millions of shattered glass bubbles. It creates a crunching sound underfoot, distinct and light. It is the volcano's attempt to make something as light as a leaf, a playful mimicry of the ocean's vegetation crafted from the fire of the earth. It reminds us of the incredible versatility of molten rock, that the same substance which builds mountains can also form these paper-thin, amber sheets that dance in the surf. From the shattered glass that mimics the present life, we turn our gaze to the layers of ash that preserve the past. We drift to the science of tephrochronology, the art of using volcanic ash as the clock of the earth. Because a large eruption spreads ash over thousands of miles in a matter of hours, it lays down a single, uniform blanket across the entire landscape, a specific moment in time frozen in a layer of grey. Visualize a cliff face or a canyon wall where the layers of the earth are exposed. You see the browns of soil, the reds of clay, and then, cutting through them like a sharp line, a distinct band of white or silver ash. This is a bookmark in the library of the deep time. Every time you see this stripe, you're looking at the exact same day in history, whether you're standing in a valley or on a mountain peak miles away. Think of these layers as the pages of a great book. The volcano writes the history of the world in dust. By reading the chemical signature of the ash, we can tell exactly which volcano spoke and when. It brings a sense of order to the chaos of geological time. Visualize the ash falling silently millions of years ago, covering a prehistoric forest, a lake, or a plain. It settled softly, creating a pristine horizon that was eventually buried by new earth. Now, when we find it, it serves as a timeline, a grey thread connecting the disparate stories of the ancient world into one cohesive narrative. It reminds us that the earth remembers everything, filing away the days in neat, dusty layers waiting to be read. Within these layers of ash, specifically the finer silt-like dust, the volcano performs its most delicate act of preservation. We move from the layer itself to what is hidden inside it, fossilized flora. While petrified wood preserves the heavy trunks of trees, volcanic ash has the ability to preserve the fragile, fleeting beauty of a single leaf or the wing of an insect. Visualize a prehistoric forest floor. A gentle rain of cool, fine ash begins to fall. It coats the ferns, the broad leaves of the undergrowth, and the delicate flowers. The weight of the ash presses the plant flat against the ground, sealing it in an airtight chamber. The plant matter decays away, but the impression remains perfectly moulded in the hardening stone. Picture splitting open a piece of shale or tuff millions of years later. There, embossed on the grey rock, is the perfect image of a fern frond. You can see every vein, every serrated edge, every texture of the leaf. It looks like a pencil drawing made by nature. The ash was so fine it captured the microscopic details that would otherwise have vanished in a week. It is a photograph taken in stone. We can see the insect bites on the leaves, the drops of water that were resting on them. This is the volcano as an artist, capturing the ephemeral softness of the biological world and granting it the longevity of the geological world. It is a tender preservation, saving the memory of a soft green morning that happened eons ago. But ash does not only preserve the warmth of life, sometimes it protects the cold of the ice. We travel now to the high latitudes, to the flanks of volcanoes in Iceland or the Andes, to witness the volcanic glacier. Usually the sun melts the ice in the summer, but when a volcanic eruption covers a glacier in a thick layer of dark ash or rock, a strange transformation occurs. If the layer is thin, the dark rock absorbs the sun and melts the ice. But if the tephra layer is thick, it acts as a heavy insulating blanket, protecting the ice from the sun's rays. The glacier beneath stops melting. It becomes a fossil glacier. Visualize a mountain slope that looks like a field of black rock. But underneath the rubble, there is pure blue ice, preserved for centuries longer than it should have existed. Sometimes, the movement of the glacier cracks the ash layer, revealing the brilliant white and blue ice beneath the black stripes. It looks like the hide of a giant zebra. Black stone, white ice, black stone. This insulation allows the ice to flow further down the mountain, into warmer valleys where it would normally vanish. It is a symbiotic relationship between the fire's output and the ice's endurance. The ash, born of heat, becomes the guardian of the cold. It reminds us that appearances can be deceiving. Beneath the dark, rough surface of the volcanic slope, there may lie a heart of frozen crystalline purity, protected from the weathering of the world. We leave the high ice and descend to the low swampy plains or the sea floor, where the earth bubbles not with fire but with a cold grey slurry. We arrive at the mud volcano. These are not true volcanoes driven by magma, but they mimic their fiery cousins in shape and behaviour. They are driven by deep reservoirs of pressurised gas, often methane, and ancient subterranean water mixing with clay. Visualise a landscape that looks like the surface of the moon, grey and desaturated. Rising from the cracked earth are small cones, some only a few feet high, others rising like hills. At the summit of each cone is a small crater filled with thick liquid mud. Watch the rhythm. Bloop, bloop, splash. A bubble of gas rises through the sludge, stretching the surface until it bursts, flinging droplets of grey clay onto the rim. The mud is cold to the touch. There is a scent of oil or gas in the air. These features are sometimes called griffins. They are the quiet, gurgling vents of the sedimentary world. In Azerbaijan, they can grow to be large mountains that occasionally flare up with burning gas, but mostly they just bubble patiently. It is a relaxing, hypnotic sight, the earth playing with mud. It feels like a return to childhood, to the simple pleasure of wet earth and bubbles. There is no threat here, only the steady release of pressure from the deep hydrocarbon reservoirs, creating a landscape that is constantly reshaping itself in wet grey clay. Beneath the mud, beneath the crust, beneath the tectonic plates themselves, there lies a boundary that marks the true beginning of the inner earth. We drift down to the Mohorovicic discontinuity, affectionately known as the Moho. This is the invisible floor of the crust and the ceiling of the mantle. We cannot see it, but we know it is there because of how it reflects the song of the earth. Seismic waves change speed when they hit it. Visualize this boundary as a shimmering, undulating horizon miles beneath your feet. Above it is the brittle, fractured rock of the crust where we live. Below it is the dense, ultramafic rock of the mantle, rich in olivine and pyroxene. It is a threshold of density. Imagine floating down through the solid rock, passing through the granite and the basalt, until you reach this transition zone. It is the line where the earth becomes serious, where the pressure jumps and the rock becomes something heavier, greener, and more primal. It is the hidden foundation upon which all our mountains and oceans rest. To acknowledge the Moho is to acknowledge that we live on a thin shell, a delicate skin floating on a much deeper, denser reality. It is the unseen limit, the basement of the surface world. As we cross that threshold and descend deeper, we notice a fundamental truth of our planet. The deeper you go, the warmer it becomes. This is the geothermal gradient. It is the comfort of the Earth's embrace. On the surface, we are at the mercy of the wind and the winter, but the Earth itself is a reservoir of perpetual heat. For every 100 feet you descend, the temperature rises by about 1 degree. Visualize this gradient as a warm blanket wrapped around the core. In the deep mines of the world, the walls are hot to the touch. The rock radiates a heat that has been stored for billions of years. This warmth is not violent like a volcano. It is steady, pervasive, and constant. It creates a Goldilocks zone deep underground where microorganisms thrive in the pore spaces of rocks, living entirely on the heat and chemistry of the deep. Feel this warmth rising up to meet you. It is a reminder that we live on a living battery, a sphere that generates its own energy. We are never truly cold, for the ground beneath us is always keeping the fire, holding a steady temperature that defies the freezing vacuum of space. We let this concept of planetary heat carry us away from Earth entirely, floating through the vacuum until we reach the giant amber-hued moon of Jupiter, Io. This is the most volcanically active body in our solar system. It is a world turned inside out by gravity. Caught in a tug-of-war between the massive gravity of Jupiter and the pull of the other moons, Io is kneaded like a ball of dough. This friction creates endless internal heat. Visualize the surface of Io. It is not grey or brown, but brilliant yellow, orange, red, and black, coloured by sulphur in all its forms. It looks like a pizza or a piece of abstract art. There are no impact craters here because the volcanoes pave over the surface faster than meteors can scar it. Picture a plume of sulphur dioxide rising distinct and umbrella-shaped, shooting nearly 200 miles into the black sky. Because of the low gravity and lack of wind, the plume forms a perfect symmetrical canopy before raining back down as colourful snow. It is a world of constant renewal, a celestial body that is forever resurfacing itself. It is the ultimate expression of the volcanic impulse, a moon that cannot stop erupting, painting itself in vivid colours in the lonely silence of the Jovian system. Leaving the colourful, frantic world of Io, we drift toward the inner solar system, to our sister planet, Venus. Here, covered by a thick, crushing atmosphere of carbon dioxide, the volcanism takes on a shape defined by weight. We witness the pancake domes, Farum. These are volcanoes that have been squashed by the sky. Visualize a vast, desolate plain of grey rock, baked by temperatures hot enough to melt lead. Rising from this plain are circular flat-topped hills. They look like giant coins or pancakes laid upon the ground. The lava that formed them was thick and sticky, rich in silica. But unlike on Earth, where the lava might pile up into a high dome, the immense atmospheric pressure of Venus, 90 times that of Earth, pressed down upon the eruption. It flattened the lava, forcing it to spread out sideways rather than growing up. The result is a landscape of eerie geometric perfection. These steep-sided, flat-topped cakes of stone can be miles wide but less than a mile high. There is a heavy, brooding silence here. The air is thick and still. The light is a diffused, sickly yellow. These domes are monuments to the relationship between the ground and the air. They show us that the shape of a mountain is dictated by the weight of the atmosphere above it. They are the suppressed volcanoes, the flattened dreams of a planet that wears a heavy blanket of gas, resting in the sweltering, eternal afternoon of the Venusian surface. Leaving the heavy, suffocating embrace of the Venusian atmosphere, where the weight of the sky flattens mountains into disks, we drift upward, shedding the heat and the pressure. We float through the velvet vacuum of space, turning our gaze toward a familiar companion in the night sky, our own moon. Here, in the absolute silence of the vacuum, we witness the ancient legacy of volcanism preserved in the Luna Maria. When you look up at the moon and see the dark grey patches that form the man in the moon, you're looking at vast oceans of solidified lava. Early astronomers, gazing through primitive telescopes, mistook these dark, flat plains for bodies of water, naming them Maria, the Latin word for seas. They named them poetically, the Sea of Tranquility, the Ocean of Storms. But these are seas of stone. Visualize the moment of their creation billions of years ago, when the moon was young and its interior was molten. Massive asteroids struck the surface, cracking the thin crust, and the magma from the deep bled out to fill the impact basins. Because the moon has no atmosphere to weather the rock, and no tectonic plates to recycle it, these lava plains are frozen in perfect stillness. They are the smoothest places in the solar system, vast flat horizons of basalt that have not changed in eons. Imagine standing in the centre of the Sea of Tranquility. The ground is dark, fine-grained dust and rock. The horizon is flat and close. There is no wind, no sound, only the stark contrast of the black sky and the grey ground. It is a landscape of absolute memory, a volcanic event that ended billions of years ago, yet remains perfectly preserved in the vacuum, a silent grey ocean that will never know a tide. Gravity pulls us gently away from the grey silence of the moon, drawing us back home, down through the blue atmosphere of Earth. But we do not land on a single mountain. We descend upon a landscape that rivals the lunar seas in scale. We find ourselves in the Deccan Plateau of India, or the Siberian wilderness, amidst the geological giants known as the flood basalts, often called traps. The word trap comes from the Swedish word for stairs, and when you look at these landscapes, you understand why. These are not formed by a single cone erupting, but by massive fissures in the ground that opened up to release unimaginable quantities of lava, enough to cover entire continents. This lava was fluid and hot, spreading out like water before it cooled. Then, thousands of years later, it happened again, and again. Layer upon layer of lava stacked up over millions of years, creating a layer cake of stone miles thick. As erosion eats away at the edges of these plateaus, the layers are revealed as giant terrace-like steps climbing into the sky. Visualize standing at the base of such a formation. It looks like a staircase built for titans, each step a distinct event in Earth's history, a black band of basalt separated by a thin line of soil where life tried to return before the next flood. It is a monument to the endurance of the Earth, a heavy, solid architecture that creates high, flat plateaus where clouds rest upon the floor of ancient fires. Beneath the surface of these great layers, the magma does not always find a way to the air. Sometimes it chooses a path of stealth, squeezing sideways between the existing layers of rock. This formation is known as a sill. Unlike the dike, which cuts vertically across the rock layers like a wall, the sill inserts itself horizontally, like a bookmark sliding between the pages of a closed book. Visualize the deep subterranean pressure. The magma rises, hitting a layer of hard, impenetrable stone. Unable to break through, it turns sideways, forcing its way along the bedding plane of softer rock. It lifts the entire crust above it, floating the landscape on a cushion of a liquid fire. This happens in total darkness, miles underground. The magma spreads out into a vast flat sheet, cooling slowly over centuries to become a hard, horizontal band of dolerite or granite. We only see these sills eons later, after the softer rock above has eroded away. They appear as grand, flat-topped ridges or palisades, like the Palisades along the Hudson River. Picture a sheer cliff face that looks unnaturally straight and level, a dark band of strength running parallel to the horizon. It is the architectural beam of the landscape, a hidden support structure injected by the volcano to reinforce the crust from within. Sometimes, this horizontal injection of magma is not content to simply spread out. It demands more space. It pushes upward with tremendous force but without breaking the surface, creating a formation known as a laccolith. This is the earth blister. The magma pumps into the horizontal space between rock layers, but it is too thick to spread far. Instead, it pulls in one spot, inflating like a balloon. Visualize the forest floor above such an event. You would not see fire or ash. You would simply feel the ground rising. Slowly, Over years or centuries, the flat land bulges upward into a perfect dome. The sedimentary rocks above are stretched and tilted, draping over the magma chamber like a tablecloth over a bowl. It creates a lens shape of a rock underground, flat on the bottom, domed on the top. When the magma finally cools and the soft surface rocks wash away, a solitary rounded mountain is revealed. These are the phantom mountains that seem to appear out of nowhere in flat plains. They have no crater, no lava flows, just a smooth, domed shape. It is a mountain born of hydraulic pressure, a testament to the lifting power of the liquid earth, raising the roof of the world without ever breaking a window. While the laccolith is a mountain formed in secret, other mountains tell a story of destruction and rebirth. We travel now to the concept of the Somma volcano. This is a specific and dramatic geometry, a new volcanic cone growing inside the shattered, ruined caldera of an older, larger volcano. It is the phoenix of geology. Visualize the Bay of Naples and Mount Vesuvius. The mountain we see today is actually a new peak growing out of the wreckage of a much older massive mountain called Mount Somma, which collapsed thousands of years ago. You can still see the high, jagged ridge of the old mountain wrapping around the new one like a protective arm. It looks like a cup holding an egg. This structure tells a poignant story of continuity. The old mountain destroyed itself in a cataclysm, but the fire was not extinguished. It simply found a new vent. Visualize the young, dark cone rising confidently in the center, while the ancient, green-covered cliffs of the ancestor mountain stand in a semicircle behind it. It is a geological embrace, a nesting doll of stone that visualizes the cycle of life, death, and rebirth. It reminds us that the volcano is not the mountain itself, but the conduit. The mountain is just the temporary shape the fire takes, and when one shape falls, another rises to take its place. From the classic grey and green of Vesuvius, we transport our senses to the Great Rift Valley of Tanzania to witness the strangest lava on Earth, flowing from the volcano Oldoinyo Lengai. This is the only active volcano in the world that erupts carbonatite lava. Unlike the silica-based lavas we've imagined so far, which are red, hot and viscous, this lava is unique. It is much cooler, erupting at only about 900 degrees Fahrenheit, and it is chemically more similar to washing soda than to rock. Visualize a night eruption here. The lava does not glow red. It erupts as a fluid, jet-black liquid that flows like motor oil or muddy water. It surges down the slopes in dark, river-like ribbons that are almost invisible against the night, save for a dull, reddish glow in the very heart of the flow. But the true magic happens when it cools. Within hours of touching the air, this black lava undergoes a chemical transformation. It absorbs moisture and turns a brilliant powdery white. The landscape around this volcano looks like it is covered in snow, but it is actually soft, crumbling white rock. The sound of the cooling lava is like the tinkling of broken glass. Imagine walking on this snow under the hot African sun. It is brittle and crunches underfoot, dissolving easily in the rain. It is a surreal, monochrome landscape, black rivers turning into white banks, a whimsical exception to every rule of volcanology, proving that the Earth's kitchen has endless recipes we're only just beginning to taste. The water that interacts with volcanic heat does not always vanish into steam. Sometimes it builds monuments of its own. We drift to the shimmering white cascades of travertine terraces, in places where volcanic heat warms limestone-rich groundwater, like Mammoth Hot Springs or Pamukkale. The water rises to the surface carrying a heavy load of dissolved calcium carbonate. Visualize the hot water bubbling out of the ground and flowing down a hillside. As it cools and releases carbon dioxide, it can no longer hold the stone it carries. It deposits the limestone in delicate white layers. Over centuries, this process builds natural dams and pools, creating a staircase of water. The terraces look like frozen waterfalls made of white marble. The water inside each terraced pool is often a brilliant clear blue reflecting the sky. The rims of the pools are draped in stalactites of stone, looking like melting wax or icing on a cake. Steam drifts lazily over the white steps. It is a soft, wet architecture, silent except for the gentle trickling of water falling from one basin to the next. The stone is smooth and chalky to the touch. It is a landscape of purity and cleansing, a volcanic sculpture garden built not by fire and explosion, but by the gentle, relentless evaporation of warm water. We pull back now, zooming out from the intimate terraces to view the curvature of the planet itself. We see the volcanic arc. This is the grand geometry of the subduction zone. Because the tectonic plate diving into the Earth is a curved shell, the melting that occurs at depth creates a curved line of volcanoes on the surface. Visualize the Aleutian Islands stretching from Alaska toward Russia, or the graceful curve of the Japanese archipelago. From high above, they look like a string of pearls draped across the dark velvet of the ocean. Each island is a bead, a volcano born from the same deep process. The curve is perfect, mathematically dictated by the geometry of a sphere. To sail along a volcanic arc is to follow a dotted line of fire. You pass one peak, and just as it dips below the horizon behind you, the next one rises ahead. It gives a sense of orderly progression to the chaos of the ocean. It is the seam of the planet, a visible stitching where two great plates are interacting. Seeing this arc reminds us of the roundness of our world, that we live on a globe where straight lines are impossible, and even the mountains must bow to the curvature of the sphere. Within the craters of these arc volcanoes, there often lies a body of water that defies the natural colour palette, the acid crater lake. These are not the fresh blue waters of a dormant caldera. These are lakes that sit directly on top of active gas vents. The water absorbs the sulphur, chlorine and minerals, becoming a highly acidic chemical bath. Visualize a lake of opaque, milky turquoise, or perhaps a vibrant jade green. The colour is unnatural, stunningly bright against the grey rock of the crater walls. It looks like paint or liquid gemstone. Steam wisps constantly from the surface, swirling in the wind. The water is warm, sometimes hot. There is a strange beauty in this toxicity. The lake is a chemical condenser, trapping the breath of the volcano in a liquid form. Nothing lives in this water. It is a dead sea of pure colour. Standing on the rim, looking down at this disk of turquoise, you feel a mix of attraction and caution. It is a vitriol pool, a jewel that warns you not to touch, a reminder that the volcano is a chemical factory as much as a heat source. Finally, we arrive at the end of the volcano's life when the fire is gone, the ashes washed away, and only the hardest bone remains. We stand before the volcanic plug, also known as the volcanic neck. When a volcano goes extinct, the magma remaining in the central vent cools and hardens into dense, solid rock. Over millions of years, the softer outer slopes of the mountain, the layers of ash and lava flows, are eroded away by wind and rain. But the plug remains. It is the fossilized throat of the volcano. Visualize the monolith of Shiprock in New Mexico, or Devil's Tower in Wyoming. A massive fluted tower of stone rising abruptly from the flat desert floor, piercing the sky. It looks like a fortress, sheer-sided and vertical. This is the cast of the inner conduit. We are seeing the shape of the tube that once carried the fire. The surrounding land has retreated, leaving this core standing in solitary majesty. It is a monument to the endurance of the core. It teaches us that what is inside, the central channel, the heart of the matter, is often the strongest part, capable of standing tall long after the outer shell has crumbled into dust. It is the final silent sentinel, guarding the memory of the mountain that once was. Standing in the shadow of that silent, enduring sentinel of stone, we arrive at the final, most profound realization of our journey. We have traversed the landscapes of fire and ice, soared through the atmosphere and dived to the crushing depths of the ocean floor. But the last wonder is not a mountain, nor a rock, nor a cloud. It is you. We speak now of the volcanic self. Consider the air filling your lungs at this very moment, the nitrogen, The carbon dioxide, the water vapour, these gases were not always here. In the infancy of the Earth, they were locked deep inside the molten rocks of the mantle. It was the volcano that released them. Over billions of years, through countless eruptions, the volcanoes exhaled the atmosphere that now swaddles the planet. Every breath you take is a gift from the geosphere, a sip of the ancient Earth's exhalation. Consider the water in your cells, the blood in your veins. As we have learned, this water was steamed out of the burning rocks, condensing to form the oceans that became the cradle of life. You are 70% volcanic steam, cooled and given form. Visualize the calcium in your bones, the iron in your blood, the magnesium that allows your muscles to relax into the mattress. These minerals were forged in the deep pressure of the crust and brought to the surface by the rising magma, weathered into soil, grown into plants, and consumed to become part of you. You're not merely an observer of the volcano, you're the volcano. You're the ash rearranged, you're the lava cooled and awakened, you're the walking, breathing memory of the fire. There is no separation between the beating of your heart and the pulsing of the magma chamber. We are all transient shapes taken by the eternal elements of the earth, rising up from the dust to experience the sun, only to eventually settle back down into the comforting, fertile soil. This is the ultimate secret. The fire is not destruction. It is the engine of your own existence. You're safe because you're made of the same resilient, eternal stuff as the mountain itself. You are the earth, dreaming of itself. And so, the dream begins to settle. The fire that has illuminated our journey now dims to a soft, warm ember, glowing gently in the centre of your chest. The images of the towering peaks, the flowing rivers of gold, and the sparkling green sands begin to dissolve, fading into the comfortable velvet darkness behind your eyes. Allow the heavy, grounding sensation of the basalt columns to transfer to your limbs. Your legs feel heavy, solid, and still, anchored to the bed like the roots of the mountain. Your arms are loose and weightless, drifting like the fine ash in the upper atmosphere. The roar of the eruption quiets down, replaced by the deep rhythmic hum of the Earth's core, a sound that matches the slow, steady cadence of your breathing. Inhale, drawing in the peace of the cooling stone. Exhale, releasing the heat, releasing the day, releasing the need to understand anything at all. You're drifting down now, sinking past the crust, past the mantle, floating comfortably in the warm, weightless suspension of the deep. There is no time here. The millions of years we have travelled are but a second in the span of eternity. The continents have stopped moving. The wind has stopped blowing. The ocean has stilled its waves to a glass-like calm. Everything is quiet. Everything is cool. Everything is exactly where it is supposed to be. You are a part of this great silent cycle, held securely by the gravity of the world. Let the darkness wrap around you like a soft, heavy blanket of volcanic ash, protective and warm. The story is finished, the stone is set, the mountain sleeps, and so do you. The journey is complete, and the silence is perfect. And now, 101 wonders are resting with you. Sleep now. Good night.